Hey everyone, welcome to my channel. Today we are going to discuss about the essential cloud networking and security. So we'll be starting in a moment. Let other people join. I know it takes 2-3 minutes to get aware and all. So let's wait for that. Looks like everyone joining. This is good. And this is going to be, today's session is going to be a longer session. So hold tight there, and you're going to learn a lot. And if you don't have any any computer background, or if you already have some background, both are fine. I'm going to start from very basics. So now let's get started. I think people are joining, so you're good to start. Okay, so very first thing, like, what exactly is computer networking? And if anyone asks you in an interview also, you have to, there is a, let's go with the way that's Wikipedia saying, and then I will define in simple words. So first, what Wikipedia is saying: a computer network is a group of computers that use a set of common communication protocol over digital interconnection for the purpose of sharing resources located or on or provided by the network nodes. Okay, now to simplify it a bit more, that computer networking is an practice of connecting computer and devices together to share resources and exchange information. Now what it's meaning? It's meaning, suppose you have 10 computers, okay, and you want to share data from one computer to another computer. Okay, you need some kind of medium to transfer the data, isn't it? And think about that, this is the need. Someone staying in US or Canada, or maybe some out of India, want to send some file to you. How can they send it? They need a medium, right? That is internet for you. And of course, internet is what? Combination of multiple, not multiple, I would say numerous, in number of networks is internet. So somehow your whatever your sender sending a file, and as a receiver you're receiving the file. There is a networking going on, guys. So we'll be coming to that, how that exactly works, a very deep dive into that. But now, to think of a common word at the starting, the computer networking is simply means connecting two or more computer together and sharing data. Sharing data between each other. Okay, that's what in simple sense a computer networking is, or it meant to be. Okay, now networking allow for sharing files, printers, internet access, as well as facilitating communication through email and instant messaging. So the modern day products you see, emails, this kind of VPNs. I will say this advanced feature. That's the file sharing, right? And a lot of other features, right? Like remote printing. Suppose you are, from phone now you can start your, you can send a instruction to your printer, and printer will print it wireless way. So there are numerous use cases, and there is no ending to it. Okay, the current modern day phones, if you're using phones, you're browsing internet through phone, or you're sending one, like you're chatting with from your friends or via Facebook, WhatsApp and all, right? So all are the product of this networking. Of course computing resources are there, but without network this would have not possible. Okay, now each device on the internet referred to as node. So the moment I'm saying nodes or client, what that means? That means that if you have a phone, if you have a computer, if you have a laptop, or any sort of computing devices, in the sense that have a computing power, like say any internet connected device, of course it has to be connected to the internet, it has to be capable of handling internet or networking. We will say that as a node. It's like computers, smartphones, even printers also are node. So anything that's connected to the internet. And if you see the diagram, just on the top of mine, so let me actually hide myself for a few seconds. And if you see, this router is like, there are many computers, how like computers mainly, or say phone or any device, any computing devices connected to the network or your router is, or are called the nodes. Okay, so that's the important one here. Let me see. Okay, now We'll understand more. We'll go more deep dive. Now I hope you guys understand what exactly is a computer network. It's simply connecting one computer with another. In simple sense, that's the networking. Okay. Now you also learn about the use cases also, and we'll learn a lot more things. This is just the starting. Now, what are the type of networking? I have said there could be like say 100 or even 1000 of computers, and one computer is connected to the other computer. Like each computer could be connected to each other, like one node connected to another, or different kind of networking will be there. Okay, and we'll be discussing that. We'll be discussing what kind of networking you have. First, compute resources are measurable quantities of computing power that can be requested, allocated, consumed for computing activities. Below are the main computing resources. I mean, not computing resources, also below the networking resources. I had to change the line anyway. So, the type of networking here are local area network. So, a LAN that connect computer devices within a small geographic area, such as home or office building. So, suppose you have your home network, right, where you have a router, you have your phone, your laptops, your printer, and everything connected to internet, right? I mean, connected to the router, right? That's a you can say LAN or local area network. Okay, and most cases you will have a thing like it will be hard because I have connected with my laptop. So there is RJ45 cable you push, that is also a medium of this LAN. You can see in the in the image how a LAN look like, right? Now, what is a wide area network or WAN? I mean, you must have heard about WAN a lot. I mean, LAN, and you heard about it. Now we are understanding what are those, right? So, wide area network or WAN connects multiple LAN together, often cross long distances such as across cities or even countries. The internet is a global WAN. What it mean? It means, see, like my home, I have multiple devices that connect to the router. Similar way, there are millions, billions of homes, okay? Maybe not billions, but at least millions of homes, right? So there each home, I mean not everyone, but most of the houses these days have the internet connection, right? Be it their phone devices, be it their their homeland, this locally network, where there are multiple devices, and combining everything, we are calling it wide area network. So each household connected to some ISPs, and that is connected to the global internet. That is calling the wide area network or WAN. Okay. Now, what is a metropolitan area network or MAN? A MAN connects a LAN or WANs within a metropolitan area such as a city. Okay, so it's more of a limited to the city. You can say the traffic light networking, where remotely there is a traffic light, right? That's a epic example of a MAN or metropolitan area network. Okay, now wireless local area network or WLAN. Okay, now it's a local area network. Only difference in normal local area network, you see there is a LAN connection, right? But there is no RJ45 cable you have. It's more of a wireless, like your Wi-Fi. So a wireless network devices to connect the network without the need of a physical cables. So you don't need an RJ45 cable like I'm using right now for better speed. But it's good if you don't want to, like modern phones, for example, you don't have that cable to put, right? Or you want to move to the like mobile, you want to carry it somewhere else, and you cannot carry a cable with it all the time, right? So that's why Wi-Fi is the most useful scenario for those cases, or wherever you don't, in laptops you don't have RJ45 cable these days, right? So those cases, wireless fidelity or Wi-Fi is the most common type of wireless networking technology you can ever see. Okay. Now, of course, there are more, and we will be covering the most common ones. So next one is the peer-to-peer or P2P. I mean, you heard about the P2P a lot. If you're a torrent guy, I know you did. Of course you did. Now, P2P network connects individual computers directly to each other rather than through a centralized server. Now, what this means and why they're saying without a centralized server? So, normal cases, suppose you are you are watching a video or a website and all, there the data or some databases, it could be centralized way, but it's actually managed by a centralized server. Okay, but P2P connection, you don't have many nodes connecting with many nodes. It's more of a one device to one device networking or connectivity. Now, here the most use case, like if you see the torrent, if you have ever go a bit deeper into the torrent, there is a thing called peer and seeding. So what they're saying, one device actually or one computing device or one node is sending data and one computer receiving it. Or okay, what maybe they're distributing between each other. That's an epic example of peer-to-peer networking. And of course, you see that remote controlling your device. I think you've heard about the software called TeamViewer. There also a P2P network goes on. The moment you connect, connect or you authorize the computer, one computer from another, it's established a P2P networking. So you can control the device, you can do a lot of stuff. Of course, there is some protocol in work, and you will learn what exactly protocol mean and what are the protocols are there. But think about, it's a system to connect one single device to another single device, and there is no in between, no middleman or no middle devices. That's the P2P network. Now, what is a storage area network now? And you can see from the image also, there is a storage device and computers getting connected. That's defined most of it. So a SAN or a SAN is a specialized high network, high speed networks that provide block level access to data storage. So what that means? Suppose you have a centralized storage, okay, and centralized storage in the sense a network connected centralized storage, where via networking or via internet one can simply go and access the block storage. And very good example is, if you have ever used cloud solution services or cloud any cloud service provider, you use a EBS volume for AWS, or maybe you are using a storage volume for other cloud providers. That is an epic example of a storage area network or a SAN, where you simply attach as many as volumes or storage you want, block storage you want to a particular host or virtual host, you can add it, right? So that's another very good example. Now we are done with the SAN. Now what is a virtual private network? Now virtual private network or a VPN, where a VPN allow remote users to securely access a private network over the internet. So suppose my home has some devices where there is no, it cannot go out of my internet and communicate with it. It has to only, it's limited to only my home, and it has some maybe a storage, for example, and that storage I can only access from my local area network. Now suppose I'm traveling and I cannot access the file. If I have very urgent requirement of it, I have not stored anywhere, I need that access. So what I could have done to avoid this situation, I could have some VPN solution in my home, where that from via VPN I can log into I suppose I'm going to travel Singapore, around 25th I will go. So there I suppose want to access some local file or some local, I have NAS storage, so some NAS storage file I want to access. So then if I have VPN solution, I can simply log into a VPN solution, and it will assume that I am actually inside my home or home local area network, and it will be easy to access that particular file. So that's kind of a very good example of a virtual private network, and that's my case. I'm saying, suppose you are working for a company, you are working remotely, but you can only work with the office internet. Maybe you are uploading file, deleting file, you are working, pushing some code, that only possible from the office network. So what you can do, you can use a VPN service where you simply go and use, you log in the VPN system and assume that your computer system is actually it's a virtual private network, right? So you'll think it's already in that particular office network and will assume the work that way. There are many software which have this capability. For example, you have this NordVPN, you have Beer VPN, you have so many VPN, right? That is capable of doing that. Okay. Now next one is that okay. Now we understand the type of the networkings. Now let's understand about the OSI model. Okay. Now if you have ever wondered how this networking works, how this exactly each of these functionality works, and there are many ways, every devices in the world must have some kind of separate architecture or something there, how they communicate each other. So suppose you are a person who speaks Tamil or maybe other language. I am a person who speaks Bengali as a Bengali, right? Now I want to communicate with you, okay? And if we don't have a common language, how can we communicate with each other? There is no possible, right? I could speak in Bengali, you don't understand, you speak in Tamil or other language which I don't understand, right? So how can it possible? We need a special, kind of a common language. So that way English language come, I can speak English and you can speak English, so we are understanding each other, right? So exact same way, all the networking devices we have currently in the market, okay, they have some kind of common language or common model they follow. One of such is the OSI model, but it's kind of depreciated, I will say, merged into some other model. We'll come to that also. But think about, this was at the origin level, this was the main player. While communicating with one device with another, it has to follow a certain model. So that was this OSI model. Now let's understand what exactly is the OSI model, what are these 7 layers of this OSI model, and more we'll learn. Okay, so what is a OSI model? So OSI or Open System Interconnection Model is a conceptual framework for understanding how the data is getting transmitted over the internet. Okay, and it is divided into 7 layers, and each of these layer performs a specific function. Like the whole purpose of this model is to send and receive data. Of course, the whole network purpose is what? I can send the data and receiver receive it. A receiver may become a sender and send me data, and as I will become a if the person who I'm communicating with becomes the sender, I am becoming a receiver. So a dual, you can say dual communication going on. Okay, I am sending, he's receiving, he's sending, I'm receiving. Okay, in that case, it's all about sending and receiving. That is all this model does. I mean, all this model is built for. Okay, so what are these physical layers are that I'm talking about? At the very basics, we have a physical layer. Now, what is this physical layer? So, a physical layer is responsible for transmitting raw bits over a physical medium, such as network segment, such as copper or fiber optic cable. So, if you have this LAN cable, I think in my bag you might be seeing some LAN cables which connecting my other devices. So, these LAN cables are a physical medium. Okay. Now, what is the data link layer or the second layer? That is, the data link layer is responsible for creating the relatable link between devices on the same network segment. It is responsible for like error detection and correction and the flow control. Example are the Ethernet, PPP, switch, bridge, all those are the data link layer. Okay. Now, the third one or the network layer. So, the network layer is responsible for routing data packets between different network. It is responsible for logical addressing and determining the best path for data travel. So, this is kind of a logical unit which defines a data is coming, going, wherever should go. Like we can have 10 devices, like I'm getting some traffic from internet. So, where this data should go, for which device it should go. Those kind of logical decision this network layer made. Okay. Then we have transport layer. So, this transport layer is responsible for ensuring data delivered reliably and in order. It is responsible for flow control and error checking. So, what this transport layer is saying? Transport layer is saying that how the data is getting transmitted. Is it like I am supposed receiving some data? Suppose you are watching you are loading some content in browser, okay? And in browser, first what will come? For example, first the base, you can say the network response headers came, then it's loading the other contents one by one. If it's randomized or it was not in proper order, something in between breaks, then what will happen? We might see some, things very jumbled up, a very bad looking website, right? So, it has to be in a proper order, the browser has to download that in a proper order and it has to be look very presentable, right? And after it complete the entire loading only, it's like if you ever try loading a browser and in middle you stop the loading, you will see like a site like a something out of this world, not so good looking, okay? So, in order to prevent that kind of scenarios, the content has to be loaded properly in order. This transmission or transport layer handle that part, okay? Then we have session layer. So, session layer is responsible for creating, managing, terminating session between the application. So, for example, you do login, log out, all that, right? So, login in what? Login in authentication, and log out is just terminating the authentication part. If you want to access some private files or some particular system access that's meant to be only for authorized users, you need authentication. That session is getting managed by this session layer. Okay, an example are what? For session layer, you have API, socket, WinSong, all those things. Okay. Now, presentation layer. This presentation layer is responsible for translating data between different formats for data compression and encryption. And I will give for example. For example, presentation you have SSL, SSH, IMAP, FTP, MPG, JPG. This is formatting is saying what it means actually, that if you ever use file formatting, each file that you write have particular formatting, right? For example, .doc for doc files, .jpg or png for image files. You have like for different type of requirements, we have different type of files. So, they follow a particular pattern, right? Now, this presentation layer actually did that one. So, some data is coming, what is the data format, is it expected or not, what they are sending, those kind of scenarios getting handled in this layer, okay. Mainly even the data encryption, data compression and encryption. So, any encryption and compression you can do in this layer also. Now, application layer, the final layer, so that the one that you see in front of your eyes, like your any application that's interact, like a browser, for example. A browser is what? Browsing, you're accessing a website, you're getting contents, you're whatever using the internet through your browser, right? So application layer is the highest level of the OSI model. It provides the interface between the application and network. It is responsible for providing services such as file transfer, email, remote login, like anything you want. Ultimately, we as a user, we don't directly interact with the session layer or presentation layer or a network layer. Those kind of layers, if you think as a normal user, you don't know anything about computer system. You don't understand all this session layer and all that, right? So you are actually interacting with this your networking services and all through your application layer or your application. For example, your mobile browser, for example, your desktop browser, you are accessing via that only, right? So these are the 7 layers of the base. You can say about when the internet start evolving. This was one of the model that we used for understanding or sending data between one particular device or network to another device or another network. That's how it started. Now each layer of this OSI model communicates with the layer directly above. You can see that physical layer is communicating with the data link. Data link is communicating with the network layer. Network layer communicating with the transport layer. And this each layer is communicating with this immediate layer. Okay, so that's how it's modeled. Now it's important to notice that the OSI model is a theoretical model. Many real world protocols combine the function of multiple layer, and some protocol may not fit nearly into a single layer. So what is saying that in modern world some other models, of course, because internet's evolving, some new model coming, some new concept are coming, and it's revolutionized the entire system or architecture, right? So that's what happened, and the next model we discuss is the one that you are actually using day-to-day basis, and that is the TCP/IP model. Okay, now what is that TCP/IP model? We discussed about the OSI model, right? Now we are going to a bit deep dive into the TCP/IP model. So the TCP/IP or transmission control or the internet protocol model is a set of networking protocols that are used to transmit data over the internet and other networks. Now it is the foundation of the internet and is used by most networks today. So that this TCP/IP model is actually getting used by all the networking devices or most of the networking devices that we see. Okay, I will not say all, because there are of course new revolution coming and new some things are there. Okay, but most of the things you see or you're going to use for say your computer networking or even the cloud networking, you will be handling the most of the time this TCP/IP traffic or UDP traffic. We'll come to that. All this transmission thing will come a bit later, but let's understand the very basics of it. Okay, so let's understand first how this TCP/IP model works. So this TCP/IP model actually have fewer layers than the OSI model. Okay, that's actually kind of an improvement. Okay, if there is fewer layer, that means the data can transmit faster. That was the logic behind this. Now the network interface layer corresponding to the physical and the data link layer of the OSI model. So if you remember last model, we have this physical and data link, like my say LAN and this connectivity with the switch and modems. So they are combining together. Okay. So the network interface layer corresponding to the physical and data link layer of the OSI model, it is responsible for transmitting data over the physical network and determining the physical address of the devices of the network. So suppose my MacBook or this laptop or any laptop I have, any phone we have. Okay, so each this devices have a unique MAC address. Okay, which helps identifying a lot of stuff. In networking level, a lot of stuff happens. We have to identify where to send and how to program such stuffs, right? So those cases, MAC address is very crucial. So it's determining what is the physical address of the device, and it's getting a physical it's getting the data from this physical device. Okay, so that's what the network model does, like converting the analog data that is received from the this any computing devices and transmitting the data. You can say the transmitting into data layer. Okay, now next one is the internet layer. Now what the internet layer is? So the internet layer corresponds to the network layer of the OSI model. Now it is the exact function as the network layer, where it is responsible for routing data packets between different networks and determining the logical address of the devices over the internet network IP address. So The network interface layer defines or like identifies the MAC address, and this internet layer defines the IP address or find out the IP address of the device. So anytime any traffic you send from your device or any of device, and each device have a unique IP address. Again, I'll be coming to the IP a very deep dive a bit later. But now think that each devices have IPs, right? And this internet layer make sure data generating from these devices, it have like is converting to data packets and is identifying, it's putting the header in this packets, making from which IP we receive the data, so that any response come or anything we have to send again to the IP, or we need to track like from what device we receive the data. So all these kind of reasons we need the IP address, and that internet layer get that IP address from the devices, okay, or assign that to the devices. Now next is the third one is the transport layer. Now transport layer corresponding to the transport layer of the OSI model. It is responsible for ensuring the data is delivered reliably and in order for error checking. This TCP/IP model actually kind of main fact is relying on this transport layer only. We will come to that later on, but think that it handle the error checking and making sure in order is getting like file getting downloaded in order, file getting uploaded in order. So all these orders, this error checking all happening in this transport layer. Okay. Now the fourth one is the application layer. Just like so it's current to the session, presentation and application. Previously application layer only application layer, right? And in the OSI model we are differentiating between presentation and session. Now they're combining session, presentation and application all together and saying it's a single layer. And it provides the interface between the application and the network and provides services such as file transfer, email, your browser, for example. A very good example is a browser, a remote login and all those kind of features. Now the most important protocols in this TCP IP model are IP or the internet model, responsible for routing data packets. TCP or transmission control protocol is responsible for reliable transfer of the data. UDP or user datagram protocol is another transport layer protocol responsible for transferring data without any reliability. And we'll come to all this in a very greater depth. No worries. Just understand for now these things are there and we are using it for now. Okay. Now between this it's like there is a difference between OSI model and TCP, although it's same, like we had OSI model which is combined few layers together and make it a TCP/IP model, and that is what we are saying here. I think we already covered that, but just for your reference again I'll be repeating myself. So if you see in OSI model we had application layer, presentation layer, session layer is combined to only application layer. We have transport layer and we have TCP/IP model also, like both have the transport layer intact. Networking layer is also intact. Only data link layer in the OSI model and physical layer is combined into network access layer into the TCP/IP model. So that is the main difference. Function wise, as I say, the less layer means the entire process getting completed faster. That was the end goal. Okay. Now let's move to the next one. So we talked about some protocols, right? Transmission control protocol, internet IP address, you see that's internet protocol address. So we will come to all that. Okay. So let's first understand what exactly is a network protocol. Okay. And of course, what are the most common network protocols you have? Okay. Now take a very pause. We talked about what till now? We talked about computer networking. We talked about types of networking. We talked about two main networking model that's all the modern computing devices currently using. You think about your phone, you think about your any other device, laptop, iPad, whatever devices you can think of. So all is speaking this common language. So while speaking English, for example, what do? We have to follow grammar, punctuations, all the standard we have for this this English language for general, right? So similar set of instruction rule set, like every particular functioning body has or functioning medium has a simple set of rules, and that you have to follow for internet as well. So the networking also have multiple protocols or rules, a set of instruction and rules which they have to follow in order to communication to happen. So the moment I'm saying anything like English, I have to make sure that my pronunciation is right. I'm speaking proper English. If I say some mixed Hindi, Bengali and English, it will be very tough for you to understand, right? So the exact same thing is happening here. We have to follow some protocols. So What is a network protocol? So in networking, a protocol is a standardized way of doing certain action, formatting data so two or more devices are able to communicate with and understand each other. So in order to for us to understand what I'm speaking, you have to know also English, right? If you don't know, you can understand what I'm saying. Similar way, a protocol is there just to make sure that one device and like multiple device follow some same protocol and they understand each other. That is why we have these networking protocols. Okay. And if you're a cloud engineer, if you're a DevOps engineer, you're whatever profession you have, you are using this kind of protocols every single day in a lot of things. Even the email part is actually a protocol, right? So that's like how this mail, the data getting exchanged, right? So you have to understand why this is required. So first thing, network protocol is set up a common instruction, common rule set that each or multiple device follow so that they can do the data exchange with each other. Now, what is do? Like addressing and like what it does. It's address and routing messages, error detection, recovery, sequencing, and flow control. This is some technical term. We'll come to that in a very greater depth later on. But think it's more of like sending data, receiving data, and making sure the data is correct, data is getting transmitted properly, there is no error, there is no interruption in between. Those getting handled by this protocol. Okay. Now, so there is a thing called protocol specifications, and a protocol specifications consist of syntax, which defines the kind of format and the message getting exchanged, semantics that specifies the action taken by each entity. So based on certain rules and the instruction, every entity or any computing device or any nodes, I'm calling all the networking devices as nodes, are doing some certain actions that of course defined by this rule set only. And we'll come to that, don't worry. Just think about networking protocol is some kind of rule that each of the devices is following. Okay. Now, there are many, I will say many, when I also don't know how many total protocols we have, but I know the most common one that I'm using day-to-day basis, and you should also know that what are the common protocols you have, so that anybody is in an interview and you have to say at least something about that. Because if it's a common protocol and you don't know and go to a cloud or DevOps engineer, as an interview, and you can't able to answer, that's a bad step. So that's why it's very basic, you have to understand. So the very first one is the TCP. Again, TCP, IP, UDP will come to very great depth. We'll understand that in next slides. But for now, just go overview. So TCP or Transmission Control Protocol is a transport layer protocol that is responsible for ensuring the data is delivered reliably and in order. It is used by many common internet applications such as web browsers, email client. Again, don't overcomplicate it, don't overthink. It's a kind of a very reliable, you can say reliable protocol that modern web browser or web application use to make sure the communication or networking happening reliably and they can confidently do that data exchange. Okay. Now, what is the UDP or User Data Account Protocol? So it's a transport layer protocol similar to TCP. Like it's also getting used for transferring data between each other. Okay, just like any other protocol in general, but it doesn't guarantee reliability. So just in TCP model, you are 100% sure the data I'm receiving is exact the same data that is the sender is sending. For UDP, it may not be that case. Sender is sending a data quickly, like as much as possible sending the data, and as a receiver, I might be receiving something, I might be missing something, but there is no way to check that. Okay, that's what is UDP for you guys. So it is often used for real-time applications such as streaming media and online gaming. Again, we'll come to the very details after a few slides. And the next one is IP or Internet Protocol. So a network protocol, it's a network layer protocol responsible for routing data packets between different network, and it is the foundation of the internet is getting used by most networks. So you see, any device that is connected to the internet must have an IP address. Again, I will come to this IP in a very deep dive, but for now think of that if you're connected to internet, you have a IP address. Now these two kind of IP addresses, private and public, we'll discuss that also after a few slides. Okay. Now you think that I'm sending data, some guys receiving data, I have to identify myself that who I am, I'm sending the data, so I have an IP, and where I'm sending, they also need some IP, so that when I send the data and when they receive the data, they know that I'm sending, and I can send only data if I know that user's IP. So we need the sending IP and the receiving IP in order to send and receive the files. Okay, we'll come to that later. Don't complicate. I will again don't complicate myself with that. I will simply say it's more of a like to communication happen to send the data in between devices. We need IP. Now the next one is the HTTP or Hypertext Transfer Protocol. It's an application layer protocol that is used for transferring data over the web, and it is the foundation of World Wide Web and used by the web browser to request and receive web pages from web servers. So there are web servers where you host a website, you host some content, and this and via browser we request the data. So we use say we are using Chrome browser for example, and then we are trying to browse say Google or say Facebook or any website. Then what we do, we type that particular URL in browser, then some kind of DNS resolution happen. We'll understand what is DNS and everything, but think about some like it requires the data from the Google server or some say Facebook server for example, whatever website you're trying to browse, and they're sending some content and our browser is showing that. So the way they are sending data, browser have to understand what they're sending, right? So there has to be some protocol that whatever the server send, browser has to understand it. Otherwise, we cannot see things. We might see Hebrew language, like nothing will understand, right? So in order not to that happen, like in order to prevent those kind of scenarios, there is a protocol that is HTTP, which read what the server is sending and present to us, and you can see beautiful websites, right? So that is happening with this HTTP protocol. Now there is HTTPS. So you can say it's a secure version of the HTTP where in normal HTTP it's possible that some hackers or some kind of security penetrator can modify the content of the receiving, which could be sometimes harmful for us. Like you are loading something that is harmful in our browser, our system can get also compromised, right? We don't want that to happen. So what HTTPS does that is make sure there is a security measurement, there is encryption going on, there is tight security in the communication system, and they make a situation that is not possible for anyone to come in the middle of this communication and corrupt the data or play with the data, force the data what you are receiving. Okay, that's why you have the HTTPS. Okay, now we understand TCP, we understand UDP, we understand IP, we understand HTTP, HTTPS. Now let's understand about the FTP or file transfer protocol. Now it's again another application layer protocol that used for transferring file between computers. It is commonly used to upload and download files from server. Suppose you have a virtual machine for example. Okay, I will not go to the very complicated server scenarios. I'll say you have a virtual machine. Okay, I think if you follow my last session, if you not, go check my last session where I explained about virtual machines. So there you suppose your virtual machine running in say any cloud service provider, could be AWS, could be Azure, could be GCP, I don't care. So anywhere your virtual server running. Now in order to operate that particular you need to upload some kind of file, could be any file, or you have to download some file from there. Okay, you can easily do that with the help of this FTP protocol. So you can simply download file, and there are a lot of ways to do that, but one of the very common or most favorite sometime you can say protocol for uploading and download some file is the FTP protocol. So use FTP for that use case. Okay, now next one we have DHCP or dynamic host configuration protocol. It's a network protocol that allow the server to dynamically assign IP addresses to the client devices on a network, and it helps to automate the process of configuring IP address on network. So simply suppose you have a router and we have no devices for example, so it will not have IP and anything. The moment you connect with your Wi-Fi, maybe you connect your this LAN cable to your computer, the router has to define some IP for your device. Okay, so that process actually happen by this DHCP or dynamic host configuration protocol. Okay, lot of things but yeah, these are the actually very common protocols you should know. Again, it's not possible to remember everything in a single day. What you should do, like anyway while working with things, you will start to it will be burned into your brain the moment you start using it. Or otherwise, before going to interview, you just quickly have a look over this document I will share maybe tomorrow for example, or maybe today night. Whenever I share, you can download the document and then it can work as a reference, okay, for interviews and all this kind of stuff. Okay, then next commonly used protocols are this. Post office protocol or POP3 is designed for receiving incoming emails. So suppose, I mean, this kind of this protocol actually was very famous one time, but then some new protocol came and that became famous. But mainly before the new protocol came, that is IMAP, that will discuss a bit later. So before that, POP was very famous, okay, to receive the emails. Now we have simple mail transfer protocol. The name suggests you are transferring the email, like you are sending the email. So this sending of the email, there is most, this only, I think most probably only protocol is this one. SMTP is designed to send and distribute outgoing email. Now to send an email to any recipient, you have to use this SMTP protocol, okay, and there are actually not much reference you'll find in normal website or all, but there is two kind of transmission, okay. One is the transactional, that suppose you are receiving OTP emails, you are receiving say not government notification, but any important email that come, we say that is a transactional email. And any bulk email like this loan guy send you this with Priya, Angel Priya and all this with the names, they send you emails, right? With horrible name they send you emails, for example. Those are called actually spam. I will not say like, that's a spam email, but we call it, in our language we call it a bulk email, okay, or promotional email, more formal word we say instead of spamming. So these two kind of mail we can generate with the SMTP protocol. So each cloud service provider, you will get two options, like mostly these two options, like what kind of email you want to send. You want to send like transactional, very important, that cost will be higher, or do you want to send some kind of junks or promotions, whatever you want to say. Based on that, the pricing actually get a bit different. Transaction is of course costly because you're sending some important information, and like most cases this promotion is cheaper. But again, each cloud service provider a very large pool of free messaging, so sometimes even you may not have to pay for this, okay. I think 60,000 or 1 lakh emails are free. So anyway, we will come to that when we discuss about cloud part, we will come to this more, but for now this is it. Okay, so next one is secure shell or SSH, okay. So this secure shell or SSH, also known as secure shell or secure socket shell, okay, because ultimately you are connecting over not web socket but a socket, okay, and we will come to that on my Linux part. I think next week I have a Linux session, right, there I will cover this SSH in a very deep dive mode, okay. So secure shell or secure socket shell is a network protocol that gives users, particularly system administrator, a secure way to connect or to connect or access a computer. Like this virtual machines I was talking about. You want to connect with these virtual instances. There are few more ways, but I think most famous way is actually using this SSH or secure shell to connect with those kind of virtual machines over the internet. Okay. So this is of course you are connecting from your terminal or console to the particular computer. They have to have a common way, common method to communication to happen, right? That's you have a protocol or rules or instruction set, right? So that's is secure shell. Then we have RTMP or real time messaging protocol. So it is it's a part of it is part of the technology that makes live streaming possible. RTMP primary role is to deliver content from an encoder to an online video host. Like for example, I am doing video streaming. Like I am using a software called Ecamm, where it's it's encoding my video formats and all. It's a live streaming, by the way, right? And it's sending to YouTube server. Then it is following some certain protocols. Okay, this is RTMP, real time messaging protocol. How I'm sending my video feeds to the Google host, like YouTube host, and then they're distributing to you guys. Okay. This is a RTMP, very good example. Okay. Now you have ARP or address resolution protocol. So it is a network protocol that is used to map a network address such as IP address to a physical address, and on a local network it is a link layer protocol that is used to convert IP address to MAC address. So sometimes we receive data and we might want to know like for which device. So we have IP, we have MAC address, we need a mapping between these two. So this address resolution protocol handle that part. The moment I am receiving some data for a particular IP, we can using address resolution protocol, we understand for which device actually we are receiving the data. Okay, that's why you have a ARP or address resolution protocol. Okay, the next one is the telnet or terminal emulation protocol. Telnet is an application layer protocol that enables a user to communicate with a remote device. A Telnet client is installed on the user's machine, which access the command line interface of another remote machine that runs a Telnet server program. So ultimately, what happening? You have, whatever server you have, in that server you are installing a Telnet server program, and to connect with the Telnet server program or that with that virtual machine where is you are running this Telnet server program, in your local computer or your own PC, you have to install a Telnet client. Via the Telnet client, you are communicating with the Telnet server. That what is this protocol does. Okay. And for today's session, final protocol is actually this IMAP or IMAP4. That is the latest version 4. I will say it's version 4 is actually getting used by the most of the devices. And this IMAP Internet Mail Access Protocol is a protocol that is receiving email from the mail server. It allows users to access email messages from multiple devices and location and keep their message on the server even after they have downloaded to a local device. IMAP also support more advanced features like searching specific messages, like message flags, which is used to mark the messages and read, delete important messages. All this kind of flags we said, right? Okay, and we'll come to that. What this means. And of course, first let me give some use case. Like you have Apple Mail, you have Microsoft Outlook, you have web-based email. Let's say for example Gmail. Everyone uses this IMAP or Internet Mail Access Protocol, where you normally you can search for the emails, you can search for the sender, you can search for different, you can set flags, you can set spam, important, read, promotional, all that you can set, right? So those things you do by the IMAP. So of course you had POP, but things evolve. You need, like, even version 4 of IMAP is there. Like I think there are future versions also IMAP, if I'm remembering right. So IMAP is what you are using. If you are using any email client these days, behind the scenes IMAP doing its job. So IMAP is actually getting the messages, downloading the message from the mail server, and then you can access it. Okay. So these are the most common protocols. Oh, lot to learn, right? Now we discuss how much? We discuss about what is component networking, types of networking. We understand how, like, what is the model of this networking, how they communicate with each other. Then you understand protocol is a medium where, or you can say the language you speak. Okay, for that one, like kind of a common medium, a common instruction, common rule that few, like, a device has to follow to communicate with particular server scenarios or communication to happen. This protocol is there. And these are the protocols we talked about: TCP, UDP, IP. We talked about IMAP, POP, FTP, SSH. All this protocol, and all the protocol that I've discussed, we are using in our. If you are already working as a system admin, cloud solution architect, DevOps engineer, or a programmer, you are using this in your daily lives. So that's why very important. Okay. And as I promised that I will discuss more on this TCP and UDP a very greater depth. Now that is the time. We will go to a very depth, in depth we'll learn about this TCP and UDP. Okay. Now let's understand what exactly is this this transport is. So what is transport or network transport? So network transport refers to the mechanism by which the data is getting transferred between the device or a computer network. So how it's getting transferred from my device to maybe some other device, okay? Or maybe, for example, I have this phone. From this phone I have to transfer data to this phone as a compute device, or from this phone to my back there is a computer or there is a laptop to that laptop. How this data can be sent? That is the transport, okay? So this network transport refers to the mechanism by which the data getting transferred between the devices on a computer network. Of course, all these devices has to connect to my network for the communication or transport to happen, of course. Now this can include protocols such as TCP, which is transmission control protocol, UDP, user datagram protocol, which handle the reliable and efficient transfer of data, as well as other protocols such as ICMP, Internet Control Messaging Protocol. Now you understand what it is, right? Which handle error and control of the messages. Okay, and this transport layer of the OSI model is responsible for providing an end-to-end communication services for this application is responsible for the reliable delivery of the data, right? And this reliability part we will discuss. Which one is more reliable? And I think you understand somewhat now which is the most reliable one, but we'll come to that. Okay. The very first one, transmission control protocol. So transmission control protocol is a connection oriented, meaning once a connection had been established, the data can be transmitted to two directions. So bidirectional, you can say the happening. So device A and device B, in between two devices there is a communication happening, and it's a bidirectional. So is device A sending data to device B, is B sending acknowledgement to A device and A sending acknowledgement to the B device. That is what happening, and we'll come to that. So TCP has built-in mechanism to check for errors and to guarantee that is data getting delivered in order which is sent. So it's sending a data in order 1, 2, 3, 4, 5, 6 to 10. This device also receiving the same order 1, 2, 3, 4, 5, 6, 7, 8, 10. Same order is getting maintained. Okay. Now, making it a perfect protocol for transferring information like still images, data files, web pages. I was explaining, right? You cannot have if jumble up data come to your browser, it will be in the wrong formatting and your browser cannot show the web page. It will show something, a very creepy site it will show you, right? So which will not happen if you have a TCP in place, or why TCP data is getting transferred. Of course, in TCP only you do this kind of work. So, but while TCP is instantly reliable, its feedback mechanism also result in a larger overhead, translating to a greater use of available bandwidth on a network. So, what it's saying, it's simply saying that since it's happening in order, so it's sending data, it's acknowledging it, it's sending the acknowledgement to this device and this device sending acknowledgement to again to this device, and making sure data getting transferred 100% reliable way. That to happen, there is a waiting happening, there is a handshaking happening. Of course, there is some time, there is some networking overhead for additional going on, right? That is one drawback you have in TCP, but the data is reliable. The data what getting transferred from one device to another one, it have exact data what is intended to send to the receiver, and receiver receiving the exact data what the sender is sending. Okay, that's why you have a TCP in order to make sure the data getting transferred most reliable way. Okay. So that is TCP. You can see some kind of image in this left side of mine, that TCP handshake, it's sending the sync, say some data and then syncing, and say the receiver sending the sync back, and sender again saying the acknowledgement, like what I explained using these two devices is doing the exact same stuff. Okay. Now I will hide myself so that I can explain you properly this one. Okay. So now what is user datagram protocol? So user datagram protocol is the or UDP is a simpler connectionless internet protocol wherein error checking and recovery services are not required, and with UDP there is no overhead for opening a connection, maintaining a connection or terminating connection. Data is continuously getting sent to the recipient whether the data getting received or not. Okay. Now, although the UDP isn't ideal for sending an email, viewing a web page or downloading a file, it is largely preferred for real-time communication like broadcast, multicast, just like I am doing. Okay. So now what it means? So it means that it's flooding the data. So in UDP, a sender, say so this is the first example, I am sending data from this device to this device. It's sending data as much as possible, as fast or as much, like say as soon as possible sending the data, okay, based on this capability. And this one is receiving, but while receiving the data, some data can be get missed. It might not be receiving exact same order, or data can be missed. So there is no proper way to check. Okay, in TCP you had a way to check, make sure that you are receiving data in proper order, proper manner, and exact same data. But in UDP you don't have that option. The data can be receiving, can have something missing, or it's already overflowing, you cannot check for the authenticity. Okay, so that is the only drawback for this user datagram protocol. So now you understand the TCP and the UDP, right? All are the transmission control. So you ultimately in order to send and receive data, but in UDP you don't have that guarantee of the data like you get in the TCP. That's the main difference. So now you understand TCP and UDP, right? So let's jump to the next one. I promised also that I will go very deep into IP, because if you want to become a cloud engineer, or if you want to become a DevOps engineer in general, or if you want to work with some kind of network application in future, you have to know IP in very, very, very deep way. Trust me, you will have to know that. Okay. Now, what is an IP, or why I'm so much insisting on learning the IP very well? So, IP or Internet Protocol. So, the Internet Protocol is a protocol. What is protocol? Like set of rules for routing and addressing packet of data, so that they can travel across network and arrive at the correct destination. And like ultimately what IP is there, or Internet Protocol, like these rules are there to make sure like this one have a IP and this one have a IP. So this device know to which device is sending the data, and this have a IP. So if it's sending the data to this IP, is receiving the exact same data. So in order to that happen, there is a IP or Internet Protocol to make sure sender sending the data and receiver receiving it. In order to that happen, you need the IP, and we will come to more on that what is IP address and all. So the data traversing the internet is divided into smaller pieces. So suppose from this device I am sending some data, okay. But if I say suppose I am sending even 1 MB or 2 MB, whatever size I feel, could be 1 GB, 1 terabyte, doesn't matter. When I am sending the data actually getting broken into multiple pieces. We call it packets or data packets, okay. And this packets now is ready to transfer from transfer via the network or internet, okay. And the receiver receive it, and when the receiver receive it, they combine all the data together and it form the actual file or data that is the user wanted to send or the sender wanted to send, okay. That's why packet is important, because in the packet itself, the data packet, when they break a smaller file, bigger data or any data in general, when they are forming this like smaller packets from the large data or whatever the data you have, in that data packet itself they mention what is the source IP, what is the destination IP, what is the way of this data getting transmitted, like what protocol, is it TCP, is it UDP, is it ICMP, whatever the protocol is. So that is getting defined in the data packet itself, okay. That's why it's important to know how there is a packet thing is there, how this data can transferred, and for debugging purpose also you might sometimes have to debug data packets to understand maybe abnormality of the data, or maybe to understand some scenarios like Wireshark is there which will help you with that. So anyway, there is like for now understand the data has to travel, it is broken into packets, and these packets have the information who is the sender and who is the receiver, okay. Now, and this information help router to send the packets to the right place. Suppose a sender sending data and via the internet is come to our router, and our router now have to understand which or where should I send the data. It has the IP, and IP you know the address protocol which know the MAC address of the device. So this is like router know to which device to send the data, and it's sending the data from the packets. They know this is the packet destination. I know the what is the private IP and what is the kind of target of the what target device have to send the data. So router route the data to our device. That's how this IP help the router to define them, because the moment you connect your device to router have the public IP. I will come to that, and these devices that you connect to the router automatically get a private IP. So all this plays a role. Somehow you just understand that somehow when the data come to the router know which is the target device where to send the data, and that only happen because there is a IP address, okay. So that's how it's in the data, and every device or domain connect to the internet assign an IP address, and these packets are directed to the IP address attached to them. Data arrive very straight, just like I explained, okay. Now once the packet arrives at their destination, they are handled differently depending on the transport protocol is used, combination with IP. The most common transport protocol are UDP and TCP, just the one we discussed. That's why I discussed that early. So you understand now DCP, how in your brain you know Okay, it's following a rule where it's making sure data getting transferred very securely, and not just security, it's in proper order, and there is error checking mechanism. It's making sure the data is sent, the data is received. For UDP, of course, it's faster. It doesn't have any handshake mechanism. It's simply flooding the data, sending as fast as possible, and receiving as much as possible, but there is no reliability. Okay, but these two are the most common transmission protocol, you can say, for sending the data and receiving the data. Okay, now we understand what exactly is IP now. So what is IP address now? So and how this IP addressing works, that you also have to understand, right? So an IP address is the unique unique identifier assigned to a device or domain that connect to internet, and each IP address is a series of characters such as 192.168.1.1 or like via resolver, like if you have a domain, like this will via DNS resolver the IP, doesn't matter, but just say any device connected to internet will have the IP. Now internet or network in general, now which translate to human readable names such as IP address. User are able to access website without memorizing the complex series of characters. Now think about that, in order for us to communicate with any device, we need to know the public IP of the particular device. We will come to the public private, but think about, in order to for us to access resources of another computer, we have to know the IP address. Okay, but we have like say for example Google or say Facebook, they have probably millions of servers, 1,000, minimum 1,000, maximum millions of servers could be running there, right? And if you have that many servers running, can you remember for each service, for each type of service or any different scenario, there could be numerous IPs, okay, like could be n number of IPs. You cannot remember that, or any website that you browse, you cannot remember the IP, okay, because ultimately it's a server, it's a virtual machine which is a node to a network and have a public and private IP if it's open to the internet or public internet, right? So very important to understand that for entire DNS system to communicate work, it need a like what is a DNS doing? It is receiving request and actually transferring to the host, right? So when we come to the DNS chapter, like in this session itself, we'll come to DNS. We'll discuss it more detailed. But assume that that to happen, if without IP address we cannot communicate, we cannot access any other computing resources. So this IP address help humans, of course, to access a particular kind of get like access the computing resources, and DNS help us to remember, like you don't have to remember the IP addresses, we can just remember the names. That is, I think, one of the most benefit we have. And of course, like each devices have a unique IP address, so we can securely send data and receive data from IP addresses, or like this work as a medium, right? Now this I think much like one of destination return address. Okay, yes, that is a, I think, very good example. Like how can you compare the IPs? For example, when you like you want to send a letter to your friend, for example, you have to write from where you are selling your name, your address, okay, and then the letter is the content, okay. So you are sending that to a yeah, definitely Biswajit, I will give the PDF. So at the end tomorrow or tonight, that's fine. So okay, now this like IP address work exactly same way. So just like in a letter, you have to send the sender address and you have to give the receiver address also, like in letter. Similarly in IP also, you like once it's transmission to happen in like IP work as a, of course in that we get the sender data, like who is sending it, and the receiver data who is receiving it. So that work exactly same way. So here the letter is the data and sender and receiver is the IP addresses, okay, like persons IP addresses. So in short, IP address is a unique address that identifies a device on the internet or a local network, and IP stands for, of course, Internet Protocol, which is a set of rules govern the format of the data sent via internet or a local network. That's what it does, okay, for the IP. And important note that IP addresses are not random. Of course, it's not random. They are mathematically produced and allocated by Internet Assigned Number Authority, or IANA, and a division of Internet Corporation for assigned names and number, ICANN. So if you ever go to buy any domain, you have to pay a small fee for ICANN. Okay, so that is ICANN is a non-profit organization that was established in the United States in 1998 to help maintain the security of the internet and allow it to be usable by all. Each time anyone register a domain on internet, the moment you buy a domain on like say GoDaddy or Namespace or from anywhere, they go through a domain name register and have to pay small fee for ICANN to register domain. Okay, and if you see like again, let me hide myself for a moment. See, this is how the transfer the data transfer is happening. Like you have say for your for example, you have a IP 192.16.0.12 and you are sending data and it has to like data has to send to the 192.00.00.75 and via the internet you are sending the data packets and receiver receiving it. Okay, so that's I think very good example. Now let me again show myself. Okay, so now you understand what is IP and what is the IP address. Now, very important to understand the IPv4 like is IP packet and IPv4 and IPv6 because while working with cloud systems or like not like any computer system in networking, specifically cloud networking part also, you will have to deal with the IPv4 and IPv6. So understand this IPv4 concept and IPv concept very minutely. Okay. Now, what is an IP packet? I explained that. Let me explain again. That is fine. So in networking, a packet is a small segment of a larger data. So if you have a big file, it's getting a big content or any content, any file or any data at all is actually get is getting converted into smaller data packets. That is what the network packets are. And this data sent over computer networks such as internet and divided into packets. These packets are then recombined by the computer or device that receive them. So whoever is the receiver, after receiving they recombine it. Okay. Now, like we understand the IP packet. Now, what is the IP version? So packet that hold internet protocol data carry a 4-bit version number as the first field in the header. Currently, only IPv4 and 6 are IPv4 and V6 packets are seen in the internet having IP version number 4 and 6 respectively. And this version number is carried by a 4-bit field. Only number 0 to 15 can be assigned, but only 4 and 6 are active in the market. You guys also know. So how it look like? How this packet look like? See this in top you can see two diagrams. For example, IPv4 in the first field is the version field. Is it IPv4 field? IPv4 packet or it's IPv6 packet? That get defined by the version field. So we have version, we have header length, we have type of service, and we have total length, we have identification, IP flags, fragment, offset, time to leave, or TTL, protocol, header, checksum, like source address, destination. I told you, right? There, like while the data gets sent, they like a later. You have to have that sender and receiver, right? So if you see the IP packets, either V4 or V6, wherever you see, both has the similar kind of fields. Okay. Now and see version, these fields are common in each kind of packets. Okay. Now what is, let's learn about the a bit more about this IPv4. So IPv4 is an IP version that is widely used by this used to identify devices on a network using an addressing system, and it was first version of IP deployed to production in the ARPANET. Okay, I also don't know the exact full name, so be it like that. In 1983, it uses 32-bit address scheme to store to the power 32 addresses, which is more than 4 billion addresses, and it is considered to be primary internet protocol that carries 94% of the internet traffic. I think could be more also. Now, what is saying that it's a certain unique identification address that is assigned to any device connect to a network. Okay, and it was first deployed in I think what field is 1983. Now it like when initially was like implemented, or the conceptual and like is released, it has 4 billion addresses, but it's also coming to like it's getting filled. Okay, so much demand, so many site, so many devices, and this IP pool actually finishing up. Okay, now to handle that, what we are having, we have the IPv6. So IPv6 is the most recent version of the internet protocol. This new IP address version is being deployed to fulfill the need of more internet addresses, because 4 billion is not enough. So it was aimed to resolve issues that are associated with IPv4 with 120 bit. See, IPv4 was 32 bit, but IPv6 is 128 bit address space. It allows 340 undecillion unique. I also don't know what this is, but it's of course a lot more than you can imagine. Okay, and IPv6 also called the IPNG, or Internet Protocol for the Next Generation, because after I say soon enough this IPv4 address is going to get all finished up. Okay, and if you see now also who are looking forward, or any new computation solution for big network getting deployed, even though there is IPv4, there like most these users are, I mean most these companies or enterprise companies or solution providers are actually aiming for the IPv6, because the IP you have more pool IP address, right? So it's kind of a benefit. Okay, and Internet Engineer Task Force initiated in early 1994. So they knew this might happen in 1995. Of course, could be even before that, but this task force initiated in early 1994, and the design and development of the suite are now called IPv6. So IPv4 you had, now the requirement increased, there is more requirement of IP addresses. That's why you have the IPv6 in place. Okay, and that's why very important to know. So I mean we are saying IPv4, we are saying IPv6. What exactly are this means? People don't know, which is wrong thing, which is not good. If you go to interview and they ask you what is IPv4, why you should use IPv4, why not do you use IPv6, or why should you use IPv6, not use IPv4, you need to have some solid basic understanding to answer that. That you can only do if you know this. And suppose they say we are sending some data packet, how you will know who is the receiver and who is the sender? You see, we'll simply check the data header field, or we will simply check the version field of this particular packet, and we'll know it, right? Those are the important stuff that you have to answer in different interviews based on the scenarios or the position you are applying for. Okay. You can see the IP header, I think IPv4 header 6 kind of common, mainly version, the type of service, or the say the length, header length, identification, mainly the time to leave, protocol, which protocol this the packet has to be transferred. So those all you are defining in the IPv4 header itself. Okay. So now you understand IPv packets, or IP sorry not IP packets, IP packets, or the data packets. You understand what is IPv4, you understand what is IPv6. Now let's move to the next one. Okay, and of course we are still going to talk about the IP, because it's a lot is there. Okay, that's why. Okay, now type of IP addresses. So the moment you add IP addresses, in IP addresses also there are many types. Okay, and we are going to talk about this kind of what are the IP addresses that you have. First one, in IPv4, IPv addresses are divided into 5 classes, not IPv6, in 4 only. Okay, IPv6 you have so big range. So but yeah, kind of same concept for IPv6 also. So we'll think about that. So in IPv4, addresses are divided into 5 classes, A, B, C, D, E. Okay, these are the class, and each class has a specific range of valid IP addresses, and the class of IP addresses determines the number of bits that is used by the network prefix and the host identifier. You can say in a network, suppose you have a router and you have devices. So main router has to be defined like what are the number of IP devices I can support, okay, or IP I can assign. So those kind of requirements are there. Even if you design a network, you have to define in a sub network, like big network, then you are dividing into sub network. So in how many sub network we should define, and each sub network how much devices it can support or how much IP it has. Okay, those kind of decision we have to make. And this IP address class ranges were actually now depreciated, but it's very important to know if it ever get asked you in any interview or maybe while having a networking debate, you might have to know this basic understanding of the classes. So first, class A IP addresses. If you have a range of from 1.0.0.0 to 126.0.0 and the first octet or 8 bits is used for the network prefix, and don't again overcomplicate yourself with network prefix, host prefix, we will come to that in my cloud session. Okay, from here just understand something is going on, somehow we are defining large pool of IP addresses based on different classes, and we will make a very deep dive of this IP assigning in my cloud networking class when we cover the cloud part. For now, don't overcomplicate, don't overthink yourself. I'm just saying, see it, fine, don't try to memorize it. It's not getting even used these days, right? So class A addresses are designated to use by medium-sized organizations and are intended to be used for networks with a moderate number of hosts. So by large organization is intended to use by the network with a large number of hosts. So suppose you have a big enterprise where you have many you can say many computers, computing devices, there this class A was getting used, not now. Okay. Now this we have the class B IP addresses have a have a range of 128.0.0 to 191.255.0.0. The first 2 octets or 16 bits are used for the network prefix, and the remaining 2 octets are used for the host identifier. And class B addresses are designed to use by medium level, like medium companies have limited number of, like many but limited number of networks nodes. For that we had B IP addresses. Now for the class C IP addresses have a large have a range of, I stick to the large. So class C IP addresses have a range of 192.0.0 to 223.255.255.0, and this is the first 3 octets, 24 bits are used by the network prefix, and the remaining octets getting used for the host identifier. And class C addresses are designated to be used by small organizations that are intended to be used by networks small, say 10, 20, 100, those kind of numbers I am saying. Class C is the number. Again, could be more than that also, as much as the class C's can support. So that was the early days. Okay. Again, you have the class D address reserved for multicast addresses that were ranged from 224.0.0 to 239.255.255.255, and class E address are reserved, like these two are reserved, you cannot utilize those. Okay, reserved for experimental use, have a range of 240.0.0.0 to 254.255.255. Okay, so that was the all the main classes. So many things. Now it's worth mentioning that this classful addressing system is now depreciated and not getting used anymore. Now what we have classless. Now you understand why we are not using the classes anymore. So we are calling it classless inter-domain routing, or CIDR. Notion is getting used specifically for this, specify the IP address ranges and all, and their associated network mask. So mainly we are now, previously we are using this ABCD, but now we are using this CIDR to define the network ranges, like small network, big networks, like very large networks. We all define that using the CIDR. So what is this classless inter-domain routing? I think by the name itself now you understand, you are not using classes, that's why he's saying is classless, but there is a bit more to it. Again, I will go to very deep dive when I cover this cloud networking class while we cover the cloud chapter. But for now, let's understand a bit about this itself. Okay, so classless inter-domain routing, or CIDR. CIDR or classless, CIDR is a method of allocating IP addresses and routing internet protocol packets. It replaces the older system of IP address allocation based on classes such as A, B, C, D, mainly A, B, C. D and E is like a reserve one, so not too much to about that, right? With a more flexible system of allocating IP addresses based on their binary representation, okay? And CIDR uses a notation like 120, for example here 192.0.0 for 2.0/24. So this slashing is actually kind of dividing the network. I mean, you can divide the network in ranges. Again, I will not very on to discuss about that because it need a very dedicated session for that. That's why it might confuse you other things. So I will discuss it on my cloud class. Okay. So yeah, CIDR is a notion like 192.0.2.0/24 to represent a block of IP addresses where the number after the slash represent the number of bits used for this network position on the of the address, and it allow more efficient use of IP addresses network space, enable better aggregation of router information. Now these bits, bytes, all these things, we'll come to that later. Don't overcomplicate yourself. Think that instead of class based, we have a better system. Like any tool you use, we might have some better tools. For same thing, we have some better tool called CIDR, which are now getting used for this defining of this network addresses. And this CIDR is important because when you go for cloud networking, there you have to specify the ranges for the subnet. There you have to use this CIDR system to define a subnet or network in general will have how many IP addresses. Okay. So for that, this CIDR is very important and will come when we discuss the cloud networking part. For now, let's keep it. Okay, now since we are talking about the type of IP addresses, let's talk about a very important type. Okay, that is the based on accessibility. How can we define this? I mean, how can we say different type of IP addresses? So mainly based on the accessibility, we have two kind of IP addresses. Okay, first one is private IP. And second one is the public IP. Now take a pause here. I will come to what this is. But this is very important in respect to cloud because if you create a virtual machine and attach to internet, or attach to network, it most probably going to have two IP addresses. I am coming most probably that also come. So if it's connected to the internet, it's a public, right? So if it's a public, then it will have a public IP address if you don't enable internet for the particular instant. But it's connected to the network or virtual private network you will have. I will come to what is virtual private network and all. But think about, suppose you are connecting your devices, or like say this device have Wi-Fi and this Wi-Fi, right? Or maybe for example, I have a Raspberry Pi which have a Ethernet port, right? This one. So this Ethernet port, I am connecting Ethernet port, then RJ45 cable, we have the LAN cable, and we attach that. So all this device when you connect to our network, okay, so connect to network, then it will have the IP addresses, two kind of IP addresses. First one, the moment you are connecting these devices to my Wi-Fi or say LAN cable, it will get the IP addresses to identify for its as an identification for the router, like what is the private IP or what is the particular IP in this current local area network. We call it private, local to the router, local to us. That is the local IP, or we can say the private IP. Okay. The moment I am saying the router, for my router I have an internet. So this entire household or this entire for my as a service consumer, I will have a public IP. Okay. Or for example, you are connecting with your internet, just a phone, you are not connecting the Wi-Fi, you are connecting your phone to direct say data connection, for example. Okay, you are connecting to the tower. By phone, if you enable internet, that means you are connected to the via SIM to the tower. That means you are connected to the internet. Okay, that is your public IP. So if you like the IP that other out of your home network, others see you via your public IP. But remember that whatever devices you have in your local network, it will have separate private IP addresses to identify uniquely what is the private IP of this particular device. But the moment you are accessing internet from any of the device, it will have the same public IP. If you are connected to the home local area network from via router, then router will have the single public IP, and of course all the devices under this router will have a common public IP. Okay, so let's understand a bit more. So a private IP address is a unique IP address assigned to every device that connect to your home internet network, which includes devices like computer, tablet, smartphone, which are used in your household. Okay, like what are the household devices we connect to our router. Okay, those will have a private IP. Now, actually, this is more than what you're thinking right now. I will come to that as well. So these are used for internal networks that are not accessible for the from the internet. These addresses are usually reassigned by a network. Addresses are assigned by the network administrator and used for the devices within a local area network or a wide area network. And private IP addresses are not globally unique, are usually assigned for a reserved range of IP addresses. Example, 10.0.0.0 to 10.255.255.255 or 172.16.0.0 to 172.31.255.255 or 192.168.0.0 to 192.168.25.255. Now this is very important because if you ever created any cloud network or cloud resources on your any cloud, okay, you have to first create a VPC, right? And then in VPC, what it means, virtual private network. So private network, right? Private network can have IP addresses with these ranges only. Okay, the ranges you are seeing there, you cannot go out of these ranges. Okay, you have to define your internal network within this range. Many go for many, like of course these are the different ranges. So you have to only go for like within these ranges you can go. Okay, that's why it was like important to understand like virtual private networks. Like virtually it's a private network, like a household kind of, like assume it's a household. Okay, household, and you have set up devices. For that you are defining the network. Okay, there you have to select the IP addresses. Same here also. Now it worth noting that the device which IP addresses can be private IP addresses. Devices with private IP addresses can access the internet by using the network address translation or NAT. When we go for the cloud networking part, we'll go very deep dive into a NAT. So a NAT device or a proxy server which translate the private IP address to a public IP addresses for communication with the internet. Now this is something I'm going to cover in cloud networking. For now, this I'm repeating itself just so you can have a very overview kind of idea. So it's noting that the devices with private IP addresses can access the internet by using network address translation or NAT device. For cloud, we will have a NAT gateway or a proxy server which translate the private IP addresses to a public IP addresses for communication with the internet. So suppose I have a private internet, I can access internet via NAT gateway or NAT device also. It's like in front of my private network, we're putting a box that has internet. That is the comparison you can do here. Okay, so that is the private IP addresses. Now, what is the public IP? I think now you get a very vague view of what is public IP, but let me explain a bit more. So public IP address is an address where one primary address is associated with the whole network, and these IP addresses are assigned to a device that have a direct connection to the internet, such as servers or routers. Like server, you normally, if you have ever created a server, a virtual server for example, it's directly communicating. Of course, behind the scene there are many routers, but since it's virtual, it's directly connecting to the internet, it's getting a direct IP. Okay, so most cases, if you create many virtual instances, you will see each virtual instances will have its own public IP. Of course, it will have the public IP, private IP, and also it will have different public IP. Like difference in your household, if you have 10 devices, then 10 devices will have different private IP and different private IP, but single public IP. But if you create 10 instances or 10 virtual servers in cloud, you will, and if you have enable internet access for all these 10 virtual private servers, virtual instances, what you want to call it, it will have different private IP addresses as well and different public address. So both will be different. Okay, that's one of the very good comparison you can have. Okay, and this type of public IP addresses are provided to a router by the internet. So very good example, your router is actually which is mainly giving you internet, connect to the directly internet, and it's getting the public IP. Okay, now public IP also come in two forms: dynamic and static. Now let's understand that, and this is very important for your cloud scenario also. I will come to that. So dynamic IP address, it changes automatically, regularly. ISPs buy a large pool of IP addresses and assign them to automatically to their customers. Periodically they reassign and put like the older IP addresses back to the pool to be used for other customers. So that IP keep changing and changing. It's like every time, suppose you have a DHCP or dynamic public IP enabled for your router, so it will, every time you restart internet, restart your modem, you might see your IP getting changed. Of course, if the ISP have programmed that way. Okay. Then you have static IP addresses. So in contrast to dynamic IP addresses, static IP addresses remain consistent. So kind of like every time you restart, you like whatever you do, restart it, power gone, any reason, your IP that is assigned by the internet service provider. For example, I'm using Alliance 1 Gbps internet. I have Reliance 1 Gbps internet. So I'm getting IPs from either Reliance or like based on the network I choose or based on the router I use, I am getting IP from the Reliance Jio or this Alliance broadband, right? Same way, this guys are like this either say dynamic, any kind of public IP you are getting from the ISPs. Okay. Now the static IP in contrast to dynamic IP address, static IP addresses remain consistent. So once the network assigned an IP address, so any ISP, be it Reliance Jio, be it Alliance, once they are giving me a static IP addresses, it will not change no matter what I do. I restart it, reboot it, doesn't matter. It remains the same. Most individuals and business don't need it. Like, of course, you don't need it if you don't have a requirement. But for business that has a plan to host their website or crucial to have one static address. So they don't want the IP to be changed, or maybe you're pointing your if you have purchased a domain. Again, what is domain? If you don't know, don't worry, we'll come to that. But for example, if you have a domain and you want to and that's pointing to a web server that has a IP. What if it's a normal dynamic IP? For example, for any reason, if you had to reboot your instance or restart your instance, reboot, let's leave the reboot part. But if you restart the instance or maybe that instance has some problem, you have to move to other instance, the IP will change, right? But if you have a static IP, no matter you like restart your instance, you change to other instance, you can have the same IP as a static IP address. This is very good use case if you have if you want to have a very stable site which doesn't change. And suppose in the night you're sleeping, suddenly the instance, if you have auto scaling for example, that instance like gets terminated and it's creating a new instance. That if a new virtual machine, as I told you, the IP is going to be different, right? But if you have a static IP, you can maybe later on change that. Just automatically attach that public static IP to the new instance. You can do this kind of things. Or maybe in general, if you're rebooting, restarting an instance, if there's a static IP, then you don't have to make changes in the domain service or domain where you have purchased the domain. You don't have to make change in the domain records. That is the advantage you'll have. Okay. Now there are other use cases like this static IP. Only if you see as example, you have use case wise website IP addresses. If you have like starting a planning website, you can go with website hosting service provider. You will probably encounter two kind of website addresses. Kind of IP in general, shared IP and dedicated IP addresses. So shared IP where suppose you have a kind of IP which other people are also using. I will not say that not that secure, but it reduces the cost. And if you are going for the dedicated IP, their addresses are assigned uniquely to each website or each server. And dedicated IP address help you avoid any potential blacklist because of bad behavior from other other server or something. Dedicated IP addresses also give you the option to pulling up your website using the IP address alone instead of your domain name. So yeah, if it's a fixed dedicated IP, it will help you with that. But main reason, if you ask me, like currently you go to any cloud service provider, shared IP address, it's not that shared unless you configure to do so. They will give you a dedicated IP address. Now if you want to host say 10 website in a single IP, you can do that. Say for example using WordPress multi-site hosting, you can do that. But it's not advisable. That's when many complexities are there. So this is not advisable to do that. Okay. Now the next one is that shared. You understand the shared one, that it's shared between, like if you have a multiple website in a single IP, you can have shared on. Dedicated, you are hosting one single domain or one single site on a single IP. That is most desirable one, you can say. Okay. Okay, so you understand now about the very deep way what is a private IP and what is a public IP. Now move to the next another very good thing, which is, like I'm talking about the routers and most probably switches I will come to now. So what are this router and what are these switches, right? You must have this query in mind if you are not into the networking field, or even you are not into that you are using internet but you are not know what these are. Okay, so router look like the image above. Okay, you can see now, and like every household have a router. If you have internet, 1000% chance you have router. Okay, if you don't, you can't deny that. Okay, now if you are using some neighbor internet, that means the neighbor have the router. So ultimately there is a router. Now a router is a device that connects two or more packet switch networks or sub network into like is combined multiple network into single network. What it's saying that a router help you have this connected pool of devices where your device getting connected and all that. So in more simple words, a router is networking device that forward data packet between the computer network. So if you have like multiple device connected, it help you to, it's router means it's routing it. It's routing one data coming to say router is routing the data to a particular device via the network, or any data coming to router it's sending the data to where it's going to send. Okay, so that's the main routing device what it does. So it serves primarily two functions: managing traffic between this network by forwarding data packets to their internet IP address. So I define as IP addresses, right, where the source and destination are. So router look at that the IP where you need to send the data and send that. Okay, allowing multiple devices to use the same internet connection. Some common features of the router include, like mainly router is what? Route the data between different devices, right? Now other functionalities that a router can have, first one is the firewall. So it's a security feature that controls the incoming and outgoing network traffic based on set of the predefined security rules that you can define. Then quality of service or QoS. I think if you are using router, smart browser, for example, MI smart router or any router in like any latest router, there is a service called quality of service. It's a feature that prioritize certain type of network traffic to ensure the important data such as voice or video is transmitted with minimum delay. Suppose I have 10 devices, for example, like I don't know how many, my lot of devices in my house, right? I want to make sure while I'm doing the streaming, my laptop has the most better network, most bandwidth, or what is bandwidth and all. I'll come to that as well. For now, best internet connection I want to have for my laptop. I can define a quality of service configuration to do that, okay, in my router. Then we have virtual private network or VPN. So it's I think I talked a lot about VPN in my earlier slide. So it's a feature that allow remote user to securely access and private network over the internet. Like the use case I'm saying, I'm going to travel say 25th to 31 in Singapore. I want to access some file in my local network in my Kolkata house or say any my house where I'm staying right now. I want to access, I can access if my router have the support of this virtual private network, it would be easy for me, right? So that's the kind of feature router these days provide. Then we have the dynamic host configuration protocol. I think this DHCP protocol, I think I was telling, like dynamically assigning IP addresses to devices, and this is a very common feature that each and every router you will have. Okay, and DHCP server feature that assign IP address to devices on a network, like I told you. So routers are often integrated with networking devices such as switches, access points, modems to provide more advanced feature like wireless connectivity or internet connectivity in general. Like that's why you have router to access, browse internet properly. Behind the scene, a lot of things going on, but you are using a router to route the data, the traffic between multiple devices, right? Okay. So another kind of system, like if you let's first discuss that switch, then I will talk about the use case of these two for your cloud learning. Okay, then you have a switch. So a network switch connect devices within a network, often a local area network using a LAN, and forward data packets to the to and from these devices. And unlike a router, A switch only send the data to single device, that is internet for like, which is maybe another switch, or could be another router, or could be another user computer, and not network multiple devices. So a router, what can I have? A router, I have multiple devices. I can have like network between each devices via my router. Router handle all the stuff. But in a switch you cannot do that. In a switch, only to send and receive data to other devices. Like suppose I have these two devices and I actually have a switch in my cupboard. I forgot to take it out. Sorry. So that switch actually what it does, that if I connect more devices, it will have the internet. It will send and receive data, but it cannot, like via switch only it cannot networking between each other. If I have a router which is connected, it can handle this networking between the devices, but not a switch. Switch only used for sending and receiving the data between the network, not more than that. Okay, and see, think about like why this router and switch is very important for your cloud learning. So ultimately, virtual machines are what, right? Virtual machines are somewhere in the world. There are machines or computer running which have CPU, RAM, networking devices, which enabling these virtual machines to have internet, right? Now, ultimately, by networking only we can access the virtual instances, right? So that is what we have to understand. This behind the scenes, there is routers, still there is routers. Behind the scenes, there is still switching, there are switch. So the switch image is actually, let me hide myself for a moment. The switch you see, that is actually like for those kind of data centers, the switch getting connected with all the physical layer machines, physical machines which have the virtual machines running. Okay, that's why switch is needed for networking to happen in the data centers, or maybe in home also. If you want multiple devices, like router have only limited 4 or 5 this thing, right? So like 4 or 5 LAN connection. If you want to have more LAN connection physically connected, there you need to have these switches. Okay, great. Now let's move to the next one. Okay, so now there is, I mean, how this router works. Of course, there are some protocols. Routers also have some kind of instruction set. I will not go much deep dive into it. If you are want to become a cloud architect or very more into a cloud networking side, then this makes sense. Otherwise, not. Just know that routing protocols are there as kind of set of rules and procedure. That is, the router uses to determine the best path of forwarding data packets. These are the several types of routing protocol, each of its own strength and weakness. Some of the most common routing protocols I have explained in the slides left side. So interior gateway protocol, so that has routing information protocol, open shortest path protocol, interior gateway routing protocol, and there is exterior EGP, which have the border gateway protocol. You have hybrid routing. Under hybrid routing protocols, you have enhanced interior gateway routing protocol, or EGRP. So there are protocols are there. Again, I'm not going deep dive into it. It might not be a best use case or best. You don't have to remember all this. You were going to become a cloud architect, or cloud engineer, DevOps engineer in general. Okay, but good to know the names and all. Okay, how this works. Just a idea is enough. Okay. And the choice of routing protocol again also depends on the specific requirements of network, scalability, security, and ease of configuration. So it depends, and mainly this happens on the data center side. So you don't have to worry that much. Okay. Now, what else? As I promised, that I'm going to talk about DNS, and DNS is such a very, very important thing that as a cloud engineer, or DevOps engineer, or as a programmer in general, maybe you want to, everybody want to host their own site, right? And how this DNS works, many don't know, yet they use the DNS. So which is very important if you want to work in such kind of the cloud engineer, DevOps engineer, any positions. You need to have a very good idea on DNS, because you will be hosting site, you will be hosting website, you will be configuring all these things. If you don't have an idea how this works, or even in interview also when they ask you about DNS, it will be very bad if you don't be able to answer those. This is important. Now, what exactly is DNS? A DNS stands for Domain Name System. It's a system that translates human-friendly domain names such as Google, example.com. Give an example, but Google, Facebook, any site you can think of, into IP addresses that the computer used to identify each other on network. So in internet, again, how I can identify a person, like I'm pursuing by, I mean, you can identify me by saying you are Sandip Das. I can identify, say you are, say Guru, or you are Bishwajit, right? For example, I can say the names because we have the name. So similarly, computers or the nodes in the internet can identify each other by the IP only, right? Or can access each other by the IPs only. So this, but I mean, suppose your name is like a Russian name or maybe some name that very hard to pronounce. You cannot pronounce that better way, right? So instead of remembering the IP address, complicated IP address, the numbers, nobody can remember all the website, right? What we do, we have names to remember. Like if it's a domain name, you can easily remember google.com, you can easily remember facebook.com, right? You don't know what is the IP behind that. So in order that to happen, you have the DNS or domain name system in place, which help you to achieve that. Okay. Okay. So we are going to talk a bit more on this DNS now, and I think you go by. I mean, if you want to have your own DNS, you can go to GoDaddy, Namecheap. I think there are like even cloud service provider, for example, AWS have Router 3 where you can, or many cloud have its own services. Google domains, for example, you can go buy this kind of domains. There you can host, like if you have a server, you're pointing your domains or subdomains to the host. So you will have an application or say website, you can have that way. Okay. Now, what like how this DNS works? We'll come to that now. And very important to understand, by the way, like in interview, how they ask you how the DNS work, for example. Now we will have a solid idea. So when a user types a URL in a web browser, the browser send a request to the DNS resolver saying that resolve the domain name for me. I want to know the IP address. So a browser saying that I want to know a IP address of a domain name. How they can know it? They have to send that request to a DNS resolver. Okay. Then DNS server or DNS resolver look for the IP address that is associated with the particular domain name in its database. Okay. And it send back to the browser. So if a DNS server know that it has the IP, it know the like what is the IP for a particular domain, it send that to the browser. Now the browser then uses the IP address to connect to the browser hosting like whatever the server, like I'm saying virtual server, virtual machine have the IP. So the browser direct like now interacts with the IP address. They know the IP addresses from the DNS source. So DNS server is running, which just resolve, which only function is to resolve one domain name to the to IP addresses. And once the browser get the IP address from a DNS resolver, it try to interact with the particular IP address, right? Behind the scene, by the way, you don't see that one happening in front of your eyes. Okay. So browser then uses the IP address to connect to the server hosting the website associated with the domain name. Now, DNS server receive a request from for a domain name. It first checks that in own database is that IP address is they know the IP address or not. If the DNS server don't have that information, it send the request to the next level of the server in the DNS. And kind of here one thing you have to understand that there are different kind of websites like .in, .com, .u, right? So DNS server when it receive DNS server receive request from a domain name, it checks in own domain in own database. Then if it doesn't have the information, then it sends the request to the next level of server in the hierarchy until it reach the server that has information. So for example, we have .com resolver, .in, and each of these .in, .com we have hierarchy, different domain names. Okay, and then under that domain we have the IP associations. So that's how it works. So this DNS also play a very important role for email routing, translating domain names in email address into IP address that the mail server uses to deliver the email. DNS is also a vital part of this internet infrastructure. Without it, we couldn't be able to use use the domain names to access website or other resources on the internet. Now, all is there. Now, let's understand exactly how this routing works. I think that is very important. And you you may feel is a bit complicated, which is okay to feel if you're very new to DNS, but say it's good for understanding. You don't have to remember exact all the steps, but good to remember. Okay, so I will just hide myself so that you can see the diagram. Okay. So first step, user suppose types example.com into a web browser, and the query travels to the internet and received by a DNS recursive resolver or DNS server. Okay, then the resolver then queries the DNS root name server. Okay, like .in, .com, those are called the root name servers. So the root name server respond to the resolver with an address of the top level like domain, a DNS server, just a .com, .net, which stores the information of its domains. When searching for example.com, our request is forwarded to .com, because here could be google.com, facebook.com. So it will forward to the .com TLD, okay, or top level domain DNS server. Okay. Now the resolver then makes a request to the .com TLD. The TLD send the TLD server then respond to the with the IP, because TLD.com will have the, suppose you have purchased kind of domain that is under .com, kind of abc.com. So it will, the information will be stored in .com TLD, right, a top level domain. So their TLD server then respond with the IP addresses of the domain name server, for example.example.com. Then lastly, the recursive resolve and send a query to the domain name server. Then the IP address of the domain, for example example.com, then it's returned to the resolver from the name server. So name server is returning that, and then DNS resolver then respond to the web browser. So ultimately what happened, originally the browser sent a request to the DNS resolver, right? So now DNS resolver have the IP address and is sending back to the browser. So browser now know the IP addresses, and browser is able to make the request to the web page and making sure the and then onwards communicating directly with the IP addresses. Then the server of that IP address returns the web page to be rendered in the browser. Okay, so you can see all the steps I have defined in this diagram. You can refer to that. Okay, now let's understand the very important thing. You see, this process takes some time, right? And it might take some, there could be latency. Now in DNS we have a feature called TLS, or time to leave. Okay, so time to leave means how much the cache or the information about the domain should leave, so that when a browser, like DNS resolver also cache this, and browser also these days can have that cache. So next time when you're browsing or the same domain, it will not go to all like round robin throughout your entire this, you see how complete can be, how much process going on, right? That much is not required. Since it's in the cache itself, it's no, okay, this is the domain and this is the IP, it will communicate. Okay, now there are different kind of like domain record or rule set. We'll come to that and understand how these are different, because that's also very important to know. Let's go for that one. So the moment you are purchasing a domain, it will not work. Okay, it will simply not work. In order to work, or in order to make it work, you need is DNS records. Okay, so what are the DNS records? We'll come to that now. So a DNS record or aka zone files. You also, if you go to your domain service provider, could be GoDaddy, could be Namecheap, could be like AWS, Route50, whatever the service you're used for purchasing the domain. There you have a option to add DNS records or zone files. Name could depend based on whoever, like whichever service calling what. Okay, so these DNS records or zone files are instruction that live in an authoritative DNS server and provides information about a domain, including what is an IP address associated with the domain, how to handle the request for the domain, and the record of this this records consist of a series of text files written or is known as a DNS syntax. This DNS syntax is just a string of characters used as a command to tell DNS server what to do. Now, what it's minimum saying that this DNS records are simple text files. You can say you are simply mentioning that I have this subdomain or domain. I have to target this to a particular IP or another domain, and this instruction should live for 30 seconds, 1 minute or 1 hour, 1 day, how much time I want to catch it, you can catch the information. Okay. Now, each DNS records contains several fields of information, including a name, value, TTL or time to live, that's very important, and a class. This field specifies the domain name or a host name associated with the record. So, for example, I am accessing say Gmap for gmap.google.com. Like Google have the mapping service, right? And Gmap is the maps.google.com, for example. So that means like different subdomain is pointing to different servers, right? So or maybe different another DNS they are resolving to another DNS. I will come to that one. Okay. So this information we have to store, like this DNS server store that information. Like if we receive request on say map subdomain of the particular domain, where to redirect the user, where to redirect the traffic, that is actually defined in these records. Okay, and of course different records have different purpose to solve. We will come to that just in a minute. So the name field defines the domain name that you understand now. Host name associated with the record, the value field contains the information associated with the record. The TTL field specified how long the record should be cached by DNS resolvers. I was saying, right, if you want to access your browse website, the DNS resolver will cache it next time. It will not go through this entire process again. Last time we were like explaining, right, how this entire DNS process took time. That you don't, like, DNS resolver will not do, or even browser itself will not do, because they will do the cache based on this TTL field. That's why very important. Okay. Now you can think of a DNS records like a business listing in a Yelp. Their listing will give you a bunch of information, useful information about like what kind of business it is, what are the business hours, what is the like service they offered. Similar way, all these domain are required to have it at least essential DNS record for the users to able to access the this website or any other application or anything in general. You need to have these DNS records, otherwise it will not work. Okay. Okay, now you see, let me hide myself just for a moment so you can see the complete view here. So we have like there are many DNS type, and these are the main DNS type. You can say that first one is a record. Now what is a record? A record also mean a address record. An address record maps the domain name to an IP address. This is the most basic type of DNS record and is used to direct users to the correct IP address when they type a domain name into their browser. So what it exactly mean? The moment you are entering a kind of website at like domain name, of course, for google.com, Facebook, you are typing in browser, it will go to internet and it will of course fetch the IP. So I will not say Google, I will not give that's kind of like just for name I said it, but most sites don't do that. Only if you have a smaller website. For example, you have a WordPress website, okay, for example, and you are not configuring that much scaling, typically not that much kind of a profile and all that you want to host in a virtual machine, then you will have the public IP. If you are hosting a virtual machine which connected to the internet, it will have private IP and public IP. Now domain, you want to point your traffic from a domain name to your virtual machine, you need to point it to your IP in order to the communication to happen, right? So in order to that happen, you need to add a record or address record, or will say suppose profile.sandipdas.com or .in should point to a virtual machine where I have my like web pages that serve this my profile or my profile, for example, my resume, for example. So in order to that happen, you can use the a record where you have a only single instance or single virtual machine that can handle the request. Okay, that's why it's the most simpler one. Now, what are the other one we have? We have the mail exchange record. This maps a domain name to a mail server, like the way you want to receive and send email addresses. For that, this MX record is important, and this record used to route emails sent to addresses and a domain to connect to a mail server. Then we have the CNAME or canonical name, and this is the one that is actually getting used by all these web servers and all. Okay, like bigger companies are actually using this CNAME. Not companies in general, bigger website applications are using the CNAME, where record create an alias of existing DNS. So here you are not pointing to a particular IP. In A address you are pointing to a particular IP, but in the CNAME you are pointing that to another domain. Okay. So this record actually map a subdomain to another domain name or another subdomain name. For example, www.example.com to example or www.example to xyz.amazon.com. If you have load balancer, then it is very important that you forward the traffic from one domain to the load balancer. Okay, what is load balancer? That will also come, don't worry. So next we have name server record. This specifies the name server of a domain. This record used to specify which DNS server are responsible for resolving the domain name within a certain domain. This is where we define the domain name servers. Then we have TXT records or text record. Now it allows the storage of text-based data associated with the domain name or host name. This record can be used for various purposes, including and not limited to adding an SPF record, DMRC, or storing additional information such as description of a service and all that. Okay. Now, one very important part here that in this TXT record, it's not just about DM, ARF and all that, but mainly to make sure that there is make sure that you have the access to the particular domain. Like how as a person, how as a company, if you are providing a service provider, domain related services, how will know that you are the rightful owner of a website? This TXT record actually do the step. Like they will ask you to add a line of the TXT record, which you will add, and based on the record that you add, they will confirm, okay, you are the rightful owner of the particular domain and we can allow you certain type of services. So that is actually the TXT. Then we have start of authority. This is a record type, a DNS record that contains information about a domain name server and zone of authority. Then you have SRB. This record is type of a DNS record that it will specify the location of a service on network. Okay. Now these are the main records. Another you have the APTR or pointer record. It is the reverse of a record. Suppose you have you want to make sure IP point to a domain. You can do that using this PTR record. Kind of peculiar thing, right? You might be hearing like why, but there are certain requirement when an IP also had needed redirection to or maybe pointing to a domain. Those cases like special circumstances, there you need a PTR record. So these are the main type of DNS record. The moment you work as a DevOps engineer, cloud engineer, I think one of the common tasks you will get actually to add some kind of DNS information to this domain, this DNS record to the domain. Okay. In the cloud chapter, we will cover in more details, but it is good that now you have understanding, so that there you will win an advantage. Okay. Now let's move to the next one, and yeah, I want to discuss about the firewall. So for network, it needs security also. Like my private network, I have connected to internet, right? And somebody suddenly come and connect to my network. They can do nasty stuff with my connected other devices, right? They can do it. So in order to prevent that, there are many systems in place. One of the most common one is actually firewall. So in computing, a firewall is a network security system that monitor and controls the incoming and outgoing network traffic based on a predetermined security rules of, and a firewalls typically establish a barrier between a trusted network and an untrusted network such as the internet. Okay, because we cannot trust everything from we are getting from internet, right? And the primary goal of a firewall is to block malicious traffic requests from the and data packets while allowing legitimate traffic to go in and out. Okay, that's what the is happened. Now you have types of firewalls. So there you have packet filtering. A packet filtering firewall is a management program that can block network traffic, IP protocol, an IP address and port number. Those are the things you can block based on your requirement or instruction set. And this type of firewall is the most basic form of protection, and it's meant for smaller network like your household. Okay, and a small amount of data is analyzed and distributed according to the field standards. Now let me hide myself for the explain of other things. Okay, then you have a proxy service. A early type of firewall device. A proxy firewall serves as a gateway from one network to another network to specify application to another. It from one network to another network. You can just access via this kind of proxy service. That way, this proxy service or a device will work as a firewall. Now, this proxy server can provide additional functionality such as content caching, security by preventing direct connection from outside the network. However, this also may impact the throughput capabilities and application in the application they can support, because you are doing proxy, you are going a wired out, right? For that, there might be some latencies and all that. Now, stateful inspection. So now thought of an traditional firewall, a stateful inspection firewall allow or blocks traffic based on state, port and protocol. It monitors all the activity from the opening of connection until it closed, filtering decisions made on both administrator defined rule as well as context, which refer to using information from previous connection and packet. Like it's automatically using some kind of algorithm to check all that. Okay, but if you want to think about more advanced one, you have unified threat management firewall. So UTM typically combines in a loosely coupled way function in a stateful inspection firewall with a intrusion prevention and antivirus. It may also include additional services and often cloud management. Okay, the UTM focuses on simplicity and ease of use. So kind of additional add-on you can say for your as a firewall you can purchase or you can get for your device. Okay, now we have the finally you can say the next generation firewall or NGFW. So this firewall have evolved evolved beyond simple packet filtering or stateful inspection. Most companies are deploying next generation firewall to block modern threats such as advanced malware and application layer attacks. According to Gartner Inc. Definition, a next generation firewall must include a standard firewall capabilities like stateful inspection, intrusion detection prevention, applications security, and like other control to block any risky apps, and upgrade path to include a feature like a firmware update over internet. All those things is required in order to call it as an advanced this next generation firewall. It need all these features. Okay, now I think we are done with this this firewall. Yes, web application firewall is I think this is one of the very good point. The web application firewall you see now is the advanced firewall. Okay, but yeah, subject to cost and the service that you choose. Okay, that's a kind of a condition you have. Okay, now we we'll learn a lot about IP. We'll learn a lot of networking, transmission, a lot of stuff. Right now, let's talk about the speed, because for just for your house network or maybe for a cloud, when you go and select a virtual machine, one of the key parameter that you see is the networking speed. Is it 1 Gbps? Is it like 10 Gbps? Is it 100 Gbps? What is the speed? It matters. So a network speed measures the transfer rate of data from source system to a destination system. Now, how much data I can send and receive from internet, okay, or maybe a network in general. That's called a bandwidth. So if you go and want to purchase a internet service, internet for your house, you go to internet service provider, they will ask you how much speed you want, what is the requirement, and you have to say I want 100 Mbps or I want 500 Mbps, I want 1 Gbps, I want 10 Gbps. Based on the requirement, you tell them and they will give the solution. Of course, there is a price tag for each kind of speed. Okay, so network bandwidth, let's understand more about this and we'll come to that discussion. So network bandwidth is the amount of data that can be transferred per second. So mainly if you go to this kind of service provider, they will ask you what is the speed you want. Like 500 Mbps per second. You need a comparison, like in a second how much data I can transfer, in a minute how much data I can transfer. Those are the comparing units, right? So that is a network bandwidth. So when you have the broadband, you have this ISP service provider give you house connection. There you have to specify how much speed you want. Now combine the two, like this network speed measures and network bandwidth, you have what is called network throughput. So in a network, how fast I can transfer data, like or how I can receive and send data, that is the network throughput. Okay. Now broadband. So a broadband tell you how quickly the data can be transferred, which is your overall measure of the speed of your internet connection. This is significant for determining the speed at which your internet can perform certain tasks, such as streaming a movie or streaming, like I'm doing live streaming, right? So if I don't have a very good internet, you cannot see this good quality video and I'm explaining all these screens, right? It is not possible. So throughput is very important if you are doing certain tasks, right? Okay. Now let's understand about a few little concepts which is now you think little but will play a very impactful role when you work with this advanced cloud system and all. There you will see these things coming. If you don't have a clear idea now, that time you find it very difficult. First one is a bit. So internet speed is measured in bit per second, PPS. Okay, you must have heard about all that. And this is the smallest unit of computer information. So you will often see internet speed referred to as megabit per second, Mbps, right? That is the one. Okay, so bits per second. Now we have bytes. So byte is actually 1 byte equal to 8 bit. So we use bytes to refer how much memory is available or being transferred. So how much, say, file size, for example. So how much bytes? Bytes mean what? 8 bits is equal to 1 byte. Remember that. So then we have Mbps. So the speed you ask for your service provider or internet service provider, they will ask you how much Mbps, 10 Mbps, 100 Mbps, 100 Mbps, 500 Mbps, 1 Gbps. So this is the Mbps. Okay. So megabits per second. So this is how we gauge internet speeds or how we measure the internet speeds. These speeds represent the bandwidth of an internet connection, and which is how much faster the data can be transferred each second, like per second how much data can be transferred. Mbps, like megabits per second. Okay. Then we have Mbps. The B is smaller. Okay, sorry, B is bigger. So it's megabytes per second. Measures the file size. We are talking about like how much big, like 100 say 100 MB file or say 500 MB file, we call it, right? So how much is the file size? That is the byte here, megabytes. Then you have latency. So latency measures the delay. So doing a data transfer, how much time is taking, like how much time is taking to even reach the internet service provider. So when you make a request, it will go to the service provider and all that. There is a ping. You will see if you do any speed test, they will say the latency or ping time. That is the latency. Okay. Now, in order to data transfer happen, we need mediums, right? We need these RJ45 cables. I can show you. I don't know if you can see. Okay, I can show you like this. Then we have different networking medium. Like if you have kind of cable connection, you can have fiber connection. So there are different kind of medium. Main three are twisted pair, the RJ45 cable. Then you have coaxial, your cable lines cable. Then you have this fiber optics, the like Geo or maybe Alliance. Now these days, if you want very good speed internet, there you need fiber optics, right? Now this, how this looks like also I've given, I mean this diagram you can see, right? Now I will just hide myself for a few seconds. Okay, now you see that for each like for in twisted pair, in coaxial, fiber optic and wireless LAN also, how speed matters. So if the bandwidth is say is up to 1 Gbps, in twisted pair you can have up to 1 Gbps bandwidth. In coaxial you like cable connection, you can have 10 to 100 max. In fiber optic you can up to 10 Gbps, like that's what I'm talking about. And in wireless LAN you can actually wireless LAN now you can have up to even 300, even 400. Now 1 Gbps also this is available. So the diagram might be not like for the wireless span, not that right, but this is what I had. Now the distance part, twisted pair can go up to 100 meter. Coaxial wire can go to up to 500 meter, but fiber optic can go to up to 60 kilometer, that much. Then you have wireless LAN up to 100 meters. Price, twisted pair, you can purchase from anywhere else like LAN cable, right, for your internal home based internet. Then you have coaxial wire, inexpensive, like cable connection, that is also very cheap. But fiber optic is most expensive if you, want a very good connection in your house. Now these days Jio is making it free, but still it's a very expensive infrastructure to have. Okay. And for wireless LAN, you can just purchase this kind of, these days router itself have inbuilt modem and the Wi-Fi, so it's kind of free. So free or moderate, you can say. Okay. And learning these things so important, because the moment you go and choose virtual machine for your workload to run or application to run in a cloud, you have to make a decision how much speed that connection, that particular VM virtual machine should have. And now if you're I'm saying VM you don't understand, you should look at my previous week session, which will have links in description and details playlist as well. So anyway, but this is very important. Okay. So understand that very well. For virtual machine, you have to select a network, like how much a data transfer. You want to say request coming to the particular virtual machine, and the request, like response going to the particular, like whoever requesting the data. If the network speed is fast, the data will go fast. If the network speed is very slow, the entire request response will become slower. So people will think your site is slow, but maybe your virtual machine instance is very good, but your network itself is not that strong. That's why it's causing delay. Those things you have to keep in mind. Okay. Okay, this is the last slide of my networking. We have the security few slides, we will cover that. So for now, like we are going to learn the cloud, right, after I think next month probably. So before learning more of this cloud, there are a few concepts, if you know now, which will be very helpful for you. So that's why I keep a very short list, and I didn't put all the list, to be honest. There could be more, but I put it very short. Okay. Now first one is virtual private cloud, or VPCs. VPCs are virtual cloud network that allow you to create isolated networks within a cloud service, cloud provider infrastructure. So you go to different cloud service provider, there you create the different virtual cloud networks, right, or virtual private network. That's a VPC. Again, don't have to overcomplicate yourself. We'll talk while we discuss, right. Now next you have cloud load balancers. So this cloud load balancer distribute incoming traffic to multiple servers to ensure no single server is overwhelmed. They can also be used to provide high availability and automatic failover. So what is meaning? Suppose you have a website, okay, and suddenly you are running that website in a single virtual machine. For example, suddenly too much workload came, and what happened that your website got overloaded. So much CPU and so much RAM use that your computer cannot serve any more requests. Now that's not a desirable scenario, right? What if you have multiple instances there? The load could have come and distributed maybe 10, 20, how much instance required. You have that much instance or virtual machines where the load get distributed, so your website will not go down. Or what is the scenario that if you run one single machine, some fault happened for any reason, your single machine gone down, your website, your services will go down, people will start screaming at you, people will start blaming you, and bad words are all the way. But what if you have like multiple copy of such same machine which handling all the traffic? See, if one instance or even 2 or 3 instances go down, you have 3-4 more, or maybe automatically if you create it to fill that space, right? Those things, a load balancer is absolutely required. Those current modern application what you see, there are many application load balancers running behind the scene. You don't know, but things are running there. Okay, if you work as a DevOps engineer or cloud engineer in general, you will be working on load balancers a lot. Okay. So now you have cloud-based DNS. Now cloud-based DNS service can be used to map domain name to IP addresses, allowing users to access cloud-based resource using easily. That's like the domain name service I was talking about. You have GoDaddy and all that. Now each cloud service provider have their own tool, own service in form this kind of cloud-based DNS. For example, you have Google DNS service, you have Google Cloud DNS service, you have Amazon Route 3, right? Similarly, Azure have their DNS services. So all cloud service providers have these DNS services which help you purchase and configure all the DNS addresses in the cloud. You don't have to go to another service provider. Directly with them. Okay. So now you have cloud-based VPN. So cloud-based VPN services allow users to securely connect to cloud service provider and network from a remote location such as home or branch office. Say example, I want to access my home or my home network from Singapore, for example. I can quickly do that. Similarly, if you have an infrastructure running in cloud, you want to, and that's not open to public, maybe an intranet, could be any reason that you want to running in a private subnet, you're running so many instances. What is private subnet? You don't know, don't worry. Think about in a private space you're running some instance or private network. They are need to connect, but it doesn't have, like, then what you have to do? You have to connect to an instance that you can connect via, connect as a VPN server. Via that you have to, like, it will reside in the same network, but it will access all the resources via private VPN service. You can do all this kind of stuff. What is it, how it works, we'll come to in cloud sessions, but now understand this service there which help you to access private internet from anywhere in the world. Okay, then you have the firewall. So cloud-based firewall can be used for filter traffic, block managed traffic, which I think could be a very good example of this web application firewall for AWS, for example, or such kind of tools. Then you have WAN. So cloud-based WAN services can be connect multiple branch office or a cloud service provider to a cloud service provider network, allowing user to access cloud-based services from any location. So mainly, I will say example as a direct connect in AWS you have that works that way. Then you have cloud-based content delivery network or CDN. CDN, I think you must have heard so many times. So CDN can be used to distribute traffic across multiple servers, improving the performance and scalability of the cloud-based application. So what happens if you have multiple servers that holding the content? So and it's near. So suppose I am in Kolkata and I'm accessing some content in say US. First time I might not have in my Kolkata server the data, but what if the data, I access from the US now in Kolkata server, next time I make a request to a site, it checks that okay, in Kolkata server they have the content, they serve the content from Kolkata, it doesn't have to go to a US server. That might save a time. You may think it's negligible, but think of performance point of view, it will make an impact. Okay. Then you have the cloud-based networking function virtualization or NFV that allow you virtualize network functions such as firewall, load balancers, VPN. And as a cloud service provider, if you go and you will use this kind of stuff anyway. Now you have cloud service based defined networking. SDN allow, or this is called SDN. So SDN allow you to management of the automation of network traffic, making it easier to scale and manage cloud-based networks. Okay. Now you might not see this kind of SDN services directly, but behind the scenes, this cloud service provider in data centers or in other places they're using it. You might not see, but it's still there. Okay. And at the end, you have cloud-based network and application performance management like NPM and APM. This is also very important because we want to know how our application performing, how much fast or slow queries making, how this entire system like log collection, analyzing the logs, all these things happening. So this NPM or APM allows for the monitoring and analysis of the network and application performance, helping to identify and resolve issues that might affect performance. So there might something happening, going to happen or happening. You might predict or you might find a root cause with the help of these tools. So that's why, and examples are Dynatrace, Datadog, you have Splunk, you have ELK stack, a lot of services are there. Okay. Anyway, I'm going to discuss all this while covering the cloud part, so don't worry. Well, I think 2 hours 30 minutes, 2 and 30. See how long this session become. We covered basic and all the important topics, like even some advanced topic over networking. Whatever I discuss about in this network session, you will find that in your cloud. When you go and work in cloud networking, like with any cloud, you will see all are coming there. Now hold there, don't go. We still have to learn about the computer and cloud security, right? And I want to keep it very not that long. It's only few slides. Believe me, really small slides. Let's go through it. Okay. So let's understand what is exactly cloud security. So first computer security. So what exactly is the computer security? So computer security or cyber security or information security or the security of IT security, you call it a different name, but it's the computer security in general, is the protection of computer system and networks from attack by malicious actors that may result unauthorized information disclosure, theft or damage to hardware, software or data, as well as from the disruption or misleading of services they provide. So anything that bad can happen, we want to, like, bad can happen with computer system, we want to provide, I mean, we can do avoid all that, right? And we want to protect our system from that. That is what we call computer security. Now, in simple words, I mean, this is by Wikipedia, and if you speak in simple words, a computer security refers to the protection of computer, in simple term, protection of computer system and networks from unauthorized access. We don't want anyone to access my system. We want I, or maybe who I'm allowing to them, like, access the system, like, and use disclosure, disruption, modification, or destruction. Okay. Yeah, it's a very long session, going to be a bit long. So yeah, I mean, I have limited time, right? Only weekends. Understand? I hope you understand. So yeah, effective computer security involve a combination of technical measures such as firewall, encryption, as well as policies and procedures such as user education and incident. So it's not about secure a computer publicly using some software. You have to educate your user who is supposed to use a computer, should also understand basic security knowledge. Like, that's why even, while talking about DevOps, we say, I mean, or security or anything such, it's actually a responsibility of all the team members and everyone. It's not about the security stuff to manage the security. It's actually the basic responsibility of any person working in the company to handle the security very seriously, which doesn't happen, to be honest. But yeah, that's the thing which should be there. So yeah, so types of computer security. So there are several types. Networking security, protecting the computer networks. You have endpoint security, protecting the individual device such as computer, laptop, and mobile devices. You have application security, protecting softwares that you use or web application, those. You have data security, that is protecting data from unauthorized access. Like, you have healthcare data. Like, I don't want my healthcare data, although I have some problems with this, what we call it, cholesterol and all, but I don't want people to find exact details of what I have, right? So those kind of stuff, I don't want to be shared with publicly. Any health problems, like, that's very crucial. Or your banking information, you don't want people to know your banking information, right? In order to prevent that, we have data security, that is identity and access management, IAM. While talking about cloud part, we'll go very deep dive into it. So managing and controlling access to computer system and network by verifying identities of users and devices, this is important. Then we have disaster recovery and business continuity. Like, disaster is going to happen, we are working hard to delay it, you can say that. So because what happens, there are always, in a certain point, things going to fail. We are making sure that it's not failing now. Fail, okay, but we should have a way to recover if it fails. Okay, because system failure can happen. Even for example, cloud service providers, they can, some engineer do some misconfiguration, an entire networking system go out. Then that kind of things can happen, right? So that's what I'm coming. That if you, those kind of situation you have to handle, and not just that, planning for and responding to natural disasters, power outages, like, this is one of the very common problem. Another disruption, ensure that the critical system and data can be restored quickly and efficiently. So there has to be a way that our whatever is required to function our business has to be set up there. Some kind of, say, scenarios can happen. You have to pre-plan for that. Those things you do in disaster recovery and business continuity. So these are the type of computer security measures you can take. Okay. Now, what are the threats? Okay. So computer security threats. So there are many types of security threats, and we will be covering the most common one. And you have to, I hope you guys already know it, but I want to confirm that you know all this. Okay. So malware. So what are the malwares? So malware is a malicious software that can infect a computer and cause harm, such as viruses, Trojan horses, worms, and ransomware. Then we have phishing. So phishing is an attempt to trick user into providing sensitive, like credit card also information, such as password, credit card numbers, by disguising as a trustworthy entity. Like for example, my friend sent an email, like someone paid to my friend and sent an email, Sandip, I need very urgent money. Can you send me? I'm sending a scan code. Can you pay me some payment by UPI? That's kind of phishing. Or maybe, Sandip, can you? I need some cards to do some processing. Can you share your card data? That kind of phishing. normal people in normal sense or your friends will not ask it, to be honest. They will ask you, like, do some help. So that kind of thing. They cannot ask you the crucial information, but some are trying to attempt. Sometimes older people who are not aware of these systems on all this kind of problem is actually fall into the spray, which is unwanted, but hackers are very intelligent persons, right? So then you have social engineering, using psychological manipulation techniques to trick user into providing sensitive information or performing action that can compromise safety. Okay, that is called social engineering, and we already know a lot of ways these days. I'm not going to say about them. Then we have hacking. So attempts to gain unauthorized access to a computer system and network, typically goal of stealing data or modifying data. Then we have DDoS. That is very, very important. If you are working as a cloud engineer, DevOps engineer, one of the most common challenge you have to handle is this DDoS. And at the end of the session, few slides later, I'm going to talk about DDoS very deep details. So hang on till then, okay? So DDoS or distributed denial of service, DDoS attacks attempt to make a computer network resource unavailable to its intended users. So I want to access a website and DDoS attackers making sure that website is not available. So I will get angry on not on the attackers, but on the website, because I don't know the attackers attacking, right? So that's a form of DDoS attack. Then we have advanced persistent threats or APTs. So long-term and targeted. So yes, one of the example is that what you're saying. So yeah, so long-term and targeted attacks often carried out by nation-state actors or well-funded criminal organization with the goal of stealing information from the target organization. I think that's one of these advanced protection threats are. Now we have zero-day vulnerabilities, unpatched software. Vulnerabilities that can be exploited by attackers before the vendor even aware of the issue, or it's called this zero-day vulnerabilities. Okay. Then you have insider threat. Now security breaches can be caused by a malicious or negligent employee or a contractor with the access to it. So sometimes for example, a company hired a person as a contract, maybe as an employee, whatever it could be, and they didn't treat the employee well. Okay. In those cases, the employee can become a very bad person and share the company's crucial information with other people, or maybe competitors, right? So those, or maybe do something bad with this infrastructure or system. That is a insider threat. Then we have IoT security. So inaccurate security of Internet of Things devices such as cameras, smart cameras. Like I have a lot of cameras in my home. Then we have smart home devices. Again, my home is full of smart devices. And medical equipment such as can be easily compromised. That's why you should have protection or security, network security basically in place to make sure your network, this kind of devices are safe from those kind of threats. Okay, that is IoT security, or this kind of problem happens. So that's why that is kind of threat is there. Okay, now you have cryptojacking, using someone else's computing resources to mine. I think Edward Snowden is a very good example of what insider threat is. Okay, now cryptojacking, using someone else's computing resources to mine cryptocurrency without their knowledge. What happened in this cryptojacking was very common in earlier, even now also. Suddenly they somehow get access of the computing resources of a particular user, and they this kind of crypto mining they run, which turn out to be they're getting profit from crypto mining. Of course, all this crypto they're getting, but it's also like in the reverse effect, it's creating it's making the bills unwantedly high for, or unthinkable high for the normal users who have this system running, right? So those are called cryptojacking. But these are the very common threats we have to handle as a cloud engineer, as a DevOps engineer, as a security engineer, what do you want to call it? Because security is a kind of responsibility for every single person, right? So all these things we have to handle. Okay, now we talked about computer security, we talked about the types of threat. Yeah. Now what is the cloud security? So cloud computing, as per Wikipedia, a cloud computing security, or more simply a cloud security, refers to broad set of policies, techniques, application and control utilized through the project. Project utilize IP, data, application, services and the associated infrastructure of cloud computing It is a sub-domain of computer security. So now you learn about this computer security is kind of an extension of the computer security, because ultimately what? In cloud services, we are running virtual machines, we are using IPs, we are using virtual networks. So how it can be different than a normal computer security? It's just a most advanced, because it's a new things and new features, new system. So it will have threat. So that to solve that, or to prevent any problem to happen, we'll have new security system in place. Okay. So yeah, that's why it's more of a cloud security is more of a enhanced version of a cloud security, or maybe a part of cloud normal system security or computer security, you can say. So in simple word, a cloud security referred to the measures and technologies that are implemented to protect data, application and infrastructure associated with the cloud computing from unauthorized access, use, disclosure, disruption, modification, destruction. Like all unwanted, like no unwanted user can use the particular cloud account, or like somebody who don't deserve access, don't are not intended to have the access to a particular cloud system, any virtual machine or other services should not able to access that. Those kind of things you have to handle in cloud security, right? Now, what are the measures we should take? I myself, not by any other people, myself actually divided in these two category, primary and secondary. So cloud security principle or measures, whatever to call it. So primary is access control, controlling and monitoring who can access what in the cloud resources or cloud account. Then you have data encryption, making sure what data you're storing or processing is secure and in transit and secure after you store it at rest. Then you have network security, like securing the communication channel used by the cloud service. So however is communicating, it has to be a secure networking. Incident response, so having a plan in place to respond to security breaches and other incident. Then you have compliance. So adhering to industry regulation standards such as SOD2, PCI DSS, HIPAA. So I work for a company, there I have to go for the SOD2. I have to do my address verification, I have to do my experience verification, I have to do my employment verification. Lot of verification for SSD you need, and I have to go through security training and all and everything. So this kind of a very standard where you have to follow the SSD2 or maybe HIPAA, for example. There you have to since you are storing the records of medical records, there has to be a lot of rules and regulations there. So those have to be there for where is intended. If you don't need, fine, but you are working with say clinical data and all those data, or like say health record data, then you need HIPAA. You want to maintain a SOC standard, like a very high standard, then you have to go through the formalities of SCC2. Those things are there. PCC DIS, I forgot, but anyone know, simply feel free to comment. Now, you have monitoring and logging, so that keeping track of activity that are happening in cloud service and being able to detect and investigate potential security incident, or in general maybe you have some problem, you want to find out the root cause. There also you need to have monitoring and logging in place so that you can find the root cause. That's why it's also important. Then you have regular security assessments and protection, penetration testing, where identify and migrate vulnerabilities in the cloud environment. Okay, so that is also important. These are the primary, I will say. Now, what are the secondary, which is can be related to primary, but worth mentioning. You have virtual private cloud to create isolated. Yeah, it's okay. Guru said a good thing. BCC DSS for the banking. So I'm not into banking, but you should know if you are working in security, you want to be a security architect, a cloud security architect, you should know all these kind of standards. Now, for the secondary part, I was saying virtual private cloud to create isolated network within the cloud. Then you have multi-factor authentication, MFA should and must be enabled for all the accounts that you create with any cloud service provider. Then use security information and event management like SIEM to monitor your cloud environment and security threats. There are a lot of software available for that. Then you have web application firewall or WF to protect your web application from attacks. What are the type of attacks? We'll learn that in next slide. Now, then use the use intrusion detection and prevention system like IDPS to detect and block malicious traffic. You have VPN so that you can connect to the virtual private network securely. So these are the primary and secondary. I will suggest you to remember if you are going to work in the cloud, like become a cloud engineer, DevOps engineer, security architect. These things are very pretty basic. Okay. Okay, now the web application security measures that you should take. First, secure your coding, because if you put 1000% on the cloud security, your application, if your application lack the security principle, lack the security in general, everything is worthless. So make sure your application have the security measures in place. Then only other things, other cloud security will make sense. Otherwise, it's the bogus, all are useless. Okay. Make sure you also take care of the cloud application or any application you run that have the security measures. For example, secure coding practices, input validation sanitization, cross-site scripting protection, SQL injection protection, cross-site request forgery protection, session management or token authentication, access control, role-based authentication for applications also if required. Securely communicate, use SSH TLS certificates, use security header and content security policy CSP, do file upload validation, protect from the uploaded file, do have intrusion protection, use web application firewall WAF. I'm repeating again, but it's very important. Use web vulnerability scanners for any potential vulnerabilities. Use regular penetration testing. Like, you should test your system a lot. Okay, logging and monitoring of your web application. So web application, you will be generating a lot of logs. Keep it somewhere safe so you can analyze for root cause when it's needed. Okay, then you have logging and monitoring for web application activity. Regular security update and patch management, that is very important. Secure password management and hashing, two-factor authentication, because I think US and many countries are making two-factor authentication mandatory. So should we look for that? Using security tokens, secure session cookie management, secure error handling and messaging, protects against denial of service attack. We'll come to denial just in a few minutes. Use of intrusion detection and prevention system, IDPS. Use security information and event management, SIM. Again repeating, but this is important. Then use of security analysis, security incident management, then compliance with industry regulation while coding and all that. Use of best security practices and guidelines for your application. Regularly security training, because see, security is kind of everyone's responsibility. So if you have okay, sorry, there's a typo in the thank you Hrithikesh. I will fix that before sharing this document. So yeah, so these are the things that you should be checking that. Okay, now yes, congratulations, you reach, I think, how many 12 concurrent viewers. So we reached the final final slide. It's a long session, I know, around 3 hours, but it's important. You learn lot of things, right? For basics to advanced networking, as well as security. I was a basic security principle, even some advanced security topics also go covering, like DDoS. So what is DDoS? DDoS, or distributed denial of service, is a type of cyber attack that aims to make a network resource or a service unavailable to its intended. So suppose I am running my say training site. Okay, there I want you go and train yourself. You have like watch the videos. What if you are not able to access the videos? The site itself not available. Like right now, I'm working my site. Right, you will get a bit feel bad. You'll be not feeling that good about the site or service. Right, that is what the attackers want. Mainly, what happened. Suppose I'm running a training site and there are, like, I'm doing for free for you guys, right? Maybe many are there which even bad quality than my content, not at the good, but they're getting a large high payment. Want my site to go down, my content to go down. So they can run this kind of DDoS attacks, right? Similarly, this kind of is a very sample scenario. Maybe people don't do that. But what I'm saying, suppose a vendor having such kind of service that which another same vendor don't want that to happen. They can hire this kind of DDoS attackers and they can do attacks, or maybe some hackers for fun they are doing DDoS attack. There could be n number of reasons, but there are high chances if you are into any development, cloud application development, or maybe cloud DevOps engineer, you are hosting a site, you are managing site, you are a SRE, okay, and you are suddenly get attacked by this DDoS attack. Okay, so let's learn more about this DDoS attack. Okay, so DDoS attacks are typically launched from a large number of compromised devices such as computers, servers, and IoT devices, which are collectively referred as a botnet. So they are kind of become a botnet, like a what we can call it, kind of say devices that are not in control of the owners, become controlled by now the hackers or whoever is the malicious actor is. It come under their control, and they flood the website, they flood the services, so the services become unavailable. Okay, and these devices are of course usually infected with malware that allow the attacker and to remotely control them. Okay, and then launch the attacks. So that's what happened behind the scenes. Okay, and there are several type of also DDoS attack. Let's understand. Now, first one is the volume based attack. There is these attacks are targeted network or service with a large amount of traffic, such as ICMP or UDP floods. Then we have protocol attacks. So in protocol attack, these attacks exploit vulnerabilities in network protocol. Now you know that network protocol we discussed, right? Where you like without you understand network protocol, if I say network protocol, you will have not understanding. That's why understanding basic very important. So now you understand network protocol, network instruction set like TCP, UDP, SH could be any protocol. So you suggest SIN flood and fragment attacks to attack those one. Okay. Then you have application, and this is the most complicated attack is the application layer attacks. These attacks target specific vulnerabilities in web-based application such as HTTP flood or slow loading floods kind of attacks they do. Okay. Now these DDoS attacks can have significant impact on the availability and performance of the network service, can cause financial losses and do cause financial losses, reputational damage. You cannot handle such kind of, like if your service become unavailable due to any attack, people will say your service not that good, you cannot even handle this much traffic. So there might be those kind of scenarios. Now therefore it's very important for organizations to implement DDoS protection measures using DDoS or using such DDoS protection service, setting up DDoS protection mitigation tools, having an incident response in plan. Now we are going to talk about what are the ways you can prevent DDoS attacks. Okay, this is also very important because the moment you become cloud DevOps engineer, you have to 100% handle these kind of things. Okay, so first using a DDoS protection service. So many cloud providers and third-party companies offer DDoS protection services that can filter out this kind of malicious traffic before it even reach your application. But sometimes this become costly. So based if you're an enterprise, you have millions of dollars, why not use this service? It handles most of your headaches. But if you're not that big company yet, you should look at the next things. Use this that rate limiting that I use a lot. Okay, so limit the number of requests a user of IP addresses can make to the web application in a given time period to prevent overwhelming of the server with too many requests. So what happens? Suppose I program a website, okay, and the website I know that a user can check my website, like access their contents and all that. Maybe 500 in 5 minutes, 500 requests in 5 minutes. It cannot go 1000 requests or 2000 requests in 5 minutes. They cannot. It cannot be that crazy. So I can set a rule by rate limiting, and this rate limiting package is actually available for all programming languages. Okay, so you can install that package. You can configure like from one IP, I can have maximum 500 or 100, 200 based on requirement request in 5 minutes, 10 minutes, 20 minutes, 1 hour, however you want to configure. And you can configure those kind of stuff. Then anything go above beyond, it will generate a 4 to 9 error. Say you are requesting too many, like you are section too much. Okay, that will error will generate. Then the request will stop requesting that much. Okay, so that is one thing you can do. Then use a content delivery network. I was speaking about the CDN, right? So CDN can help you distribute traffic across multiple servers, making it more difficult for attackers to overload a single server. Like if you are running a static website and someone like for example you have Amazon CloudFront, okay, someone try to attack CloudFront, anything you're hosting, it is very hard for them. They cannot take it down. Okay, if Amazon have some misconfiguration with CDN, that's another different story. But attackers cannot attack and take it down. Okay, that's not possible with current scenario. Then we have web application firewall, WAF. So WAF or web application firewall can help detect and block malicious traffic such as traffic originating from known IP addresses, and of course this has some advanced features as well. Then we have intrusion detection and prevention system, IDPS. Now IDPS can detect and block malicious traffic in real time and can also provide alerts and when this kind of attacks happen. Now having like even with all these measures, still there can be failure. Okay, now this kind of DDoS response plans also should be in place. So have a plan in place to correspond and deal the attack, including identify network, mitigating the risk and restoring to normal service. You have to plan everything. If you can't prevent, then in this kind of scenario, if that happen, how to rebound, how to recover your services, because you don't want to make your users angry, or they don't want your user to go to other service provider, right? That's unexpected. Now regularly test and monitor. So regularly test your application for security and DDoS attacks, kind of fire drill kind of thing you should do to make sure your website or your application can handle the traffic. Note, it is important to note that one method is not foolproof, of course, that's what I'm saying, and multiple layer of protection usually required to efficiently prevent the DDoS attack. So you have to have many kind of things. Even I'm saying still you can face problem, you should have some kind of incident response ready or some kind of disaster recovery plan ready to handle these scenarios. Okay. Oh, now I think it's nearly 3 hours, but we successfully completed a session where you learn about, I think, whatever you require to learn about networking in order to handle the cloud networking, the basic cloud networking, I would say. You now know that, or in general, any whatever you need to know for in order to work in cloud networking. Now you know that. That's important. And similarly, in order to work with cloud security or computer security in general, now you have a basic idea what are the problems like threat, malicious, like this kind of viruses, malwares, and all that. How to prevent and all that. So yes, we completed the session. Good. And I think, okay, 11 people, like more than 10 people was there. I was kind of still thinking these many people are there. It's a 3 hour session and everyone is there. Thank you. And if you have any questions, you can ask. Maybe just, I think it's already too late. So you can ask me now. You have 5 minutes. You can ask me. I will give the answer. Or you can, follow me on LinkedIn and message me. And of course, if you are watching this, you are new to this channel and please subscribe the channel. Please do subscribe the channel and share this channel with others. I want to make at least the cloud and DevOps study where my field of expertise, make it free to learn so anyone can learn it. Okay. So thank you, Anand, and thank you, Guru, for staying this long. I know you stayed from beginning to end. Thank you. So yeah, thank you everyone. Hope this session you learn a lot, because these are the things. I mean, these two actually, the previous week and this week is the only theory week. Okay, I think maybe in Linux we have bit theory. Only this is the theory part. Then onwards we will have only practicals. Okay, so that is why it was very important to know all these theories. Otherwise you might get confused today. Okay, I will answer even if you get confused later on, but still it's good to know that you learn the basics now. This document I will share in LinkedIn and of course in this video description and comment. So be there. I will share it. Maybe today, I mean after a few hours I will share, or maybe tomorrow I will share. But I will share for sure. Okay. Thank you. Thank you. It is a pleasure to know. Thank you. Yeah. Thank you everyone. Bye. Have a nice day ahead, and yes, there's so much to learn. Keep learning, and see you guys maybe next week. Okay.